The United States is undergoing massive infrastructure development, with many mega projects reshaping its landscape. From massive transportation hubs to groundbreaking energy facilities, these projects are shaping up to be some of the biggest in the country yet. Today, we'll take you across the United States' biggest mega projects under construction in 2025. Let's travel over to Virginia, where one of the largest infrastructure projects in the history of the United States is underway: the Hampton Roads Bridge Tunnel Expansion. This $3.8 billion project aims to alleviate congestion on one of the busiest sections of Interstate 64. The expansion includes building two new 4-lane tunnels using advanced tunnel boring machines, significantly improving traffic flow between Hampton and Norfolk. With over 100,000 vehicles daily, the original tunnels, built in 1957 and 1976, were struggling to accommodate increasing demand. When the Hampton Roads Bridge Tunnel first opened in 1957, it replaced a ferry service, becoming the first bridge tunnel system in the world to connect two man-made islands. Initially designed to handle modest traffic projections, it quickly became overwhelmed as the regional population grew to over 1.7 million people. By the 1970s, additional tunnels were added, but even with expansions, the corridor struggled with daily backups, stretching for miles, especially during peak summer months. Recognizing the urgent need for relief, the Virginia Department of Transportation launched this ambitious expansion project. This project involves the widening of nearly 10 miles of I-64, adding new high-occupancy toll lanes, and the construction of a new pair of bored tunnels beneath the Hampton Roads waterway. This will increase the capacity from 4 to 8 lanes, easing congestion, improving safety, and enhancing regional connectivity. It includes 27 bridge replacements and widenings, geotechnical enhancements, drainage systems, environmental compliance measures, and advanced intelligent transportation systems for traffic management. One key feature of this project is the use of a massive tunnel boring machine, affectionately nicknamed Mary. Launched from the South Island, Mary is tasked with excavating two parallel tunnels, each about 8,000 feet long, and positioned 150 feet below the water surface. The tunneling process involves an intricate sequence. Mary bores to the North Island, then undergoes a 4-month turnaround before digging the second tunnel back to the South Island. The tunnels are designed to withstand extreme weather conditions, making them resilient against the unpredictable climate of Virginia. Construction began in 2020, with completion expected by the end of 2025. One of the twin tunnels is nearing completion, with traffic flow tests scheduled later this year. Crews are now focusing on finalizing structural reinforcements and integrating smart traffic management systems. The expansion will promote economic growth by supporting more efficient freight movement, enhancing the regional role as a critical hub for commerce and national defense. Let's discuss the Vogtle Electric Generating Plant, a nuclear powerhouse in Waynesboro, Georgia. Located in Burke County, this colossal power facility is the largest nuclear power plant in the United States, boasting a staggering 4,536 megawatts of generating capacity. Named after Alvin Vogtle, a former chairman of Alabama Power and Southern Company, the journey of this plant began in the late 1970s. Units 1 and 2, featuring Westinghouse pressurized water reactors with General Electric steam turbines, were completed in 1987 and 1989, respectively. These units, with a combined capacity of 2,430 megawatt, have powered millions of homes, supported by 500 48-foot tall cooling towers that dominate the Georgia skyline. In 2009, the Nuclear Regulatory Commission extended their operational licenses through 2047 and 2049, ensuring their role in the energy grid for decades to come. However, the most ambitious phase of the history of Vogtle began with the addition of Units 3 and 4. Utilizing the cutting-edge Westinghouse AP1000 reactor technology, construction kicked off in 2009 with expectations of timely completion. Yet, the project faced significant hurdles, delays, cost overruns, and even the bankruptcy of Westinghouse in 2017. Originally estimated at $14 billion, costs skyrocketed to over $34 billion by 2023, making it one of the most expensive nuclear projects in US history. Despite these challenges, Unit 3 achieved commercial operation in July 2023, marking the first new nuclear reactor in the US in over 30 years. Once completed, it will provide reliable, carbon-free electricity to about 1 million homes and businesses. Unit 4 followed closely, entering operation in April 2024. Together, they added more than 2,200 megawatts of clean energy to the grid. The construction employed advanced techniques, including modular construction, where massive prefabricated sections were assembled off-site and transported for installation. This method aimed to reduce costs and improve efficiency, though execution proved complex. Currently, the site is bustling with cranes towering over reactor domes, massive cooling towers rising into the sky, and specialized equipment for handling nuclear materials. Robotics play a significant role in ensuring precision during the reactor assembly. Full commercial operations are expected by the end of the year, marking a historic milestone for nuclear energy in the United States. But just wait until you hear about the Upper Ohio River Navigation Project in Pennsylvania. With a $2.7 billion investment, this U.S. Army Corps of Engineers project aims to replace and modernize outdated locks and dams, ensuring smooth navigation along the Ohio River. The project focuses on Emsworth, Dashields, and Montgomery locks and dams, originally built between the 1920s and 1930s. These facilities are the oldest and smallest lock chambers in the entire Ohio River navigation system and have long outlived their intended service life. The original locks and dams were constructed to support the booming industrial age, facilitating the transportation of goods like coal, steel, and raw materials. However, over the years, structural fatigue and design limitations became glaring issues. The facilities were not built with modern materials like air-entrained concrete, making them vulnerable to weather-related deterioration. Although temporary rehabilitations were carried out in the 1980s and 1990s, these were mere stopgap measures designed to extend the lifespan of the locks for an additional 25 years. By 2010 to 2015, the extended service periods had expired, leaving the structures susceptible to failure. The Upper Ohio Navigation Project aims to replace the outdated auxiliary lock chambers, which measure 56 feet wide by 360 feet long, with new 110-foot wide by 600-foot long lock chambers at each site. This size upgrade will allow the locks to accommodate larger, modern towboats without the need for time-consuming double locking. This has previously caused delays and accelerated wear and tear on the infrastructure. The new lock chambers will serve as the main locks, vastly improving operational efficiency and reducing transportation costs for industries reliant on the river. This is critical for the Pittsburgh regional economy, where river navigation supports industries like coal, steel, and manufacturing. Construction began with preparatory contracts awarded in 2020, and major contracts for the Montgomery locks and dam were scheduled for 2024. The project utilizes advanced lock extension technology along with modern concrete reinforcement techniques to ensure durability. The new locks will be larger, allowing for the passage of bigger barges and reducing wait times. The project also includes environmental mitigation measures to protect aquatic ecosystems. Fish passages and habitat restoration projects are integrated into the design to protect local wildlife. The design also incorporates energy-efficient systems to minimize the environmental impact. By 2030, the upgraded navigation system will be fully operational, ensuring the Ohio River remains a vital transportation corridor for generations to come. But next up, we have to talk about the new Albany Energy Center in Ohio, a state-of-the-art facility revolutionizing energy production. The idea for the new Albany Energy Center was born out of necessity. New Albany is strategically located in central Ohio, providing easy access to major population centers in the eastern US, including Chicago, New York, and the South. This makes it an ideal location for data centers serving a wide geographic area. This $1.5 billion natural gas-fired power plant is designed to meet the surging energy demands driven by the rapid growth of AI data centers. With tech giants like Amazon, Microsoft, Meta, and Google expanding their data center operations in Ohio, energy demand in the region has skyrocketed. The traditional grid, already strained by increasing consumption, simply couldn't keep up with the massive requirements of these hyperscale data centers. In early 2025, Power Connects outlined a facility that would directly power an adjacent data center, bypassing the overburdened grid entirely. This approach, known as behind-the-meter generation, allows the energy produced to be used exclusively on site, maximizing efficiency and minimizing transmission losses. Spanning a 48.6-acre site in Albany, the new Albany Energy Center will feature state-of-the-art natural gas turbines capable of generating up to 120 megawatts of electricity. While that's a fraction of the energy needed for some of the largest data centers in the world, like the upcoming 2 gigawatt facility of Meta in Louisiana, it's more than enough to power a large-scale data center operating 24/7. Structural framework of the plant is complete, with turbine installation underway. Testing of key systems is scheduled for later this year, with full operations expected in early 2026. The project will employ advanced combined cycle gas turbine technology, which captures waste heat from the initial power generation process to produce additional electricity. This will enhance energy efficiency and reduce carbon emissions. Data centers are also implementing water conservation measures to minimize their water usage and protect local resources. Ohio has become a hotspot for data center development, with over $23 billion committed by Amazon alone. This boom has placed immense pressure on AEP Ohio, the regional utility provider, which reported receiving requests for an astounding 30 gigawatts of service. Recognizing the strain on the grid, developers are taking matters into their own hands, building dedicated power plants to support their energy-hungry operations. Next up is the John Glenn International Airport overhaul, a $2 billion upgrade that will transform air travel experience in Ohio, Columbus. This mega project aims to modernize infrastructure of the airport, enhance passenger experience, and support the booming economy of the region. Officially kicked off in December 2023, this mega project is scheduled for completion by 2029. The current terminal at John Glenn International Airport, originally built in 1958, has long struggled to keep pace with the demands of modern air travel. With passenger numbers surging to over 8.7 million travelers passing through John Glenn and nearby Rickenbacker airports in 2023, there was an urgent need to expand and upgrade the facilities. The new terminal is designed to handle up to 13 million passengers annually, ensuring Columbus remains competitive as a key business and tourism destination. The project is being overseen by Hensel Phelps, a construction management firm renowned for handling complex infrastructure projects. The new terminal will rise on the site of an existing parking lot south of International Gateway, with easy access from Interstate 670. This strategic placement will streamline traffic flow and improve connectivity for travelers. Key features of the new terminal include 36 gates, including 2 dedicated international gates for expanded global connectivity. There is a centralized security checkpoint near the entrance, built to enhance efficiency and reduce wait times. Pedestrian bridge connects the terminal to a new ground transportation center, rental car facility, and a 5,000 space parking garage. Them a light-filled marketplace showcasing local food, beverage, and retail options, creating a vibrant, welcoming atmosphere for travelers. Architecturally, the terminal will boast a modern entry canopy, sleek concourses, and spacious curbside levels for separate arrivals and departures, easing congestion. New passenger terminals with advanced security checkpoints, spacious waiting areas, and modern amenities. The design emphasizes natural lighting and open spaces for a more pleasant travel experience. Currently, the site is occupied with heavy-duty cranes, turbine assembly equipment, and precision piping systems. Advanced control systems are being installed to ensure optimal plant performance. The runway upgrades are on schedule, and this one is expected to be fully operational by 2027. But the project hasn't been without controversy. Prolonged negotiations between local trade unions and the airport authority delayed initial progress. Unions pushed for a comprehensive agreement to secure prevailing wages and worker benefits. Moreover, the project has set a 25% diversity business partner goal, translating to $400 million in contracts for small businesses and minority, women, and veteran-owned firms. This commitment ensures the project benefits not just travelers, but the local economy and workforce. Next up, we have to talk about the OC Streetcar project in Orange County, California. With an investment of $423 million, this modern light rail system will improve public transit by linking Santa Ana and Garden Grove. The OC Streetcar spanned 6.68 kilometers, featuring 10 stops in each direction and serving key locations, including the Santa Ana Regional Transportation Center and the newly constructed Harbor Transit Center in Garden Grove. What makes this project even more intriguing is its historical significance. The streetcar route largely follows the former path of the iconic Pacific Electric Railway red cars, which once connected Santa Ana to Los Angeles before being decommissioned in the 1950s. Construction for the OC Streetcar officially broke ground on November 30th, 2018, with initial plans targeting a 2021 operational launch. However, due to unforeseen challenges, including construction delays, legal disputes, and even the discovery of historical artifacts, the projected revenue service date has been pushed to August 2025. Despite these setbacks, the project has steadily progressed, with organizations committed to delivering a reliable and efficient transit solution. The streetcar will operate as a double-tracked system, ensuring smoother and more frequent service. The route will run curbside on city streets between the Santa Ana station and Rate Street, transitioning into a dedicated right-of-way westward. This design reduces conflicts with regular traffic, improving safety and efficiency. Additionally, the project includes constructing new bridges over the Santa Ana River and Westminster Avenue, replacing outdated infrastructure to meet modern safety standards. The OC Streetcar will deploy 8 Siemens S700 light rail vehicles, known for their energy efficiency and capacity to accommodate up to 180 passengers per car. These vehicles will be powered by overhead electric lines operating at 750 volts direct current, reinforcing the project's commitment to sustainability. Service is expected to run from 6 a.m. to 11 p.m. on weekdays, with extended hours on weekends, ensuring accessibility for both daily commuters and leisure travelers. The project also includes pedestrian-friendly infrastructure, bike lanes, and green spaces along the route. This modern transit system will significantly improve access to major employment hubs, including the Santa Ana Civic Center, which houses over 38,000 jobs, and provides seamless connections to 18 existing bus lines and Metrolink stations. Projections estimate daily ridership between 6,000 to 7,300 passengers, highlighting its potential impact on reducing vehicle emissions and traffic congestion. Construction activities include track laying, station development, and electrical system installation. Specialized rail construction equipment and heavy machinery are used to ensure precision and safety. The first streetcars are scheduled for testing later this year, with full operations expected in 2026. But we have to talk about the Las Vegas Convention Center Loop. This mega project is a revolutionary underground transportation system that's changing the way people move around one of the busiest convention centers in the world. Designed and constructed by Elon Musk's Boring Company, This $52.5 million project features Tesla-powered autonomous electric shuttles operating through tunnels beneath the Las Vegas Convention Center. The system is designed to eliminate surface traffic, reducing travel time across the 200-acre convention center to under 2 minutes. Opened in 2021, the Loop has quickly become an iconic example of how urban transit can be reimagined for the future. The idea was simple yet bold. Eliminate surface traffic congestion at the sprawling Las Vegas Convention Center by moving people underground. The system spans 2.7 kilometers at a depth of 12 meters underground, connecting key areas of the convention center that would otherwise require a 25-minute walk. Instead, the Loop shuttles passengers between stations in just under 2 minutes, using Tesla Model 3 electric vehicles. Initially driven by human operators, these cars are set to become fully autonomous in the future, enhancing efficiency and safety. State-of-the-art electric vehicles, LED-lit tunnels, and advanced traffic management systems ensure a smooth, safe, and futuristic travel experience. The initial phase of the LVCC Loop was built using a now-legacy tunnel boring machine named Godot. For expansions of the Loop, the boring company has employed its next-generation tunnel boring machine, Prufrock. This machine is designed to be even faster and more efficient than its predecessor, with features like continuous tunnel lining and the ability to launch directly from the surface, eliminating the need for large entry and exit pits. The Las Vegas Convention Center features multiple stations, including the South Station, Central Station, and Riviera Station, each strategically placed to optimize foot traffic during large events. The Loop even connects to the Las Vegas monorail at the Boingo Station, creating seamless transitions between different modes of transport. However, the journey hasn't been without challenges. In February 2024, the boring company faced violations related to workplace safety, resulting in fines totaling $112,000. Despite these setbacks, the project continued to expand, with new tunnels connecting to Resorts World, Las Vegas, Encore, Westgate, and even Harry Reid International Airport. By 2025, the vision is to create a 109-kilometer network with 55 stations, turning Las Vegas into the first city with a fully operational underground transit loop. Let's travel over to Nashville, Tennessee, where a $1.4 billion modernization plan is revamping the Nashville International Airport. BNA has seen exponential growth over the years, becoming one of the fastest-growing airports in North America. After completing the BNA vision, a $1.5 billion expansion, airport planners quickly launched the New Horizon plan to keep up with the thriving economy, music scene, and growing population of Nashville. Scheduled for completion in 2028, the project aims to position BNA as a premier international hub, ready to serve an estimated 35 million passengers annually by 2034. The New Horizon plan includes the extension of Concourse D, the reconstruction of Concourse A, significant upgrades to terminal area roadways, and a state-of-the-art baggage handling system. The Concourse D section will add 5 new gates with modern amenities, including an open-air terrace and a restaurant shaped like a vinyl record, which is a tribute to the rich musical heritage of Nashville. The terrace will overlook the city skyline, becoming a signature feature of the airport. Concourse A will be replaced by a larger 16-gate concourse, enhancing capacity for domestic and international flights. A new, advanced system will sort luggage by flight, speeding up security inspections and ensuring faster delivery of bags to and from aircraft. To ease congestion, the Tennessee Department of Transportation is relocating Donaldson Pike eastward. This critical move will improve traffic flow around the airport and its parking structures. Construction is led by Hensel Phelps, utilizing 3,500 cubic yards of concrete annually, specialized lifts, and curved materials to fit the unique architectural designs. The project also incorporates electrochromic glass, which adjusts its opacity to regulate light and temperature, improving energy efficiency. Challenges include managing airfield safety, especially crane operations near active runways, and the daily removal of 600,000 cubic yards of rock from excavation sites, which will be repurposed for future developments. The project employs heavy-duty cranes, concrete pumps, and modular construction techniques to build the new terminal and concourses. Advanced project management software is used to coordinate construction activities and minimize delays. Environmental safeguards are in place to protect local ecosystems and reduce noise pollution. The first gate of Concourse D is expected to open by March 2025, with the entire section ready by July 2025. Once completed, the expanded airport will serve as a gateway to Nashville, supporting the continued growth and development of Nashville. Let's move over to the Spring District development in Bellevue, Washington, a $2.3 billion urban transformation project. The roots of the Spring District trace back to the early 2000s when the Bell Red Corridor, a stretch of land primarily dedicated to light industry and warehouses, was identified as a key area for urban redevelopment. As businesses moved out, the city of Bellevue launched a planning study in 2005 to reimagine the area's future. In 2009, a significant zoning change allowed for mixed-use developments with buildings up to 13 stories tall, opening the door for projects like the Spring District. In 2007, real estate firm Wright Runstad and Company, in partnership with Shorenstein Properties, purchased the 36-acre site from Safeway for $68 million. The land previously housed a large distribution center, which was demolished in 2013, marking the beginning of the Spring District's transformation. The development is being constructed in 3 phases, with completion expected by 2028. The first phase began in 2015, focusing on residential and office spaces, and wrapped up in 2017. The second phase, initiated in 2016, added more commercial buildings, while the third phase, currently underway, includes additional residential units, office spaces, and a hotel. NBBJ is the master planner and architect behind the project, drawing inspiration from Portland's vibrant Pearl District. The design emphasizes sustainability, green spaces, pedestrian-friendly pathways, and seamless integration with public transit. The project employs large-scale cranes, advanced HVAC systems, and eco-friendly construction materials. Innovations in baggage handling and security screening are key highlights. By 2026, the Spring District will be a thriving innovation hub, blending sustainability, smart design, and vibrant community spaces. The Spring District will boast over 5.3 million square feet of leasable space, including 3 million square feet of office space, 1,500 residential units, parks, retail outlets, and public plazas. Major companies like Meta and the Global Innovation Exchange have already established a presence here, reinforcing the status of Bellevue as a tech hub. Recognized for its sustainable design, the Spring District earned LEED certification in 2022 due to its eco-friendly features, energy-efficient buildings, and commitment to promoting alternative transportation options. Let's discuss the Port of Corpus Christi expansion, a $2 billion project revolutionizing maritime industry in Texas. This upgrade includes deepening and widening ship channels, accommodating larger vessels, and boosting petrochemical exports. The Port of Corpus Christi has long been a vital gateway for United States exports, particularly crude oil, petrochemicals, and agricultural products. As the largest crude oil exporter in the US, the port plays a pivotal role in the energy sector of America. However, the existing infrastructure, including the aging harbor bridge built in 1959, was no longer sufficient to support the demands of modern maritime traffic. The original bridge, an engineering feat of its time, had served its purpose well, but was designed with a 50-year lifespan, which it had surpassed. To meet the needs of the larger, more efficient vessels of today, the new harbor bridge was proposed, a 506-meter-long cable-stayed bridge that would stand as one of the longest of its kind in the United States. The design includes 6 lanes for traffic and a dedicated pedestrian and bicycle path, with the bridge deck soaring 62 meters above the water, allowing massive ships to pass underneath with ease. Construction began in 2016, with an initial completion target set for 2020. However, the project quickly ran into trouble. In 2019, construction was halted after the collapse of a pedestrian bridge in Florida, an incident tied to the same engineering firm, Fig Bridge Group, working on the harbor bridge. Investigations uncovered serious design flaws, raising concerns about the structural integrity of the new bridge. Fig was removed from the project, and new engineering firms were brought in to address the issues.
Next up, it's time to travel to New York for the Bayonne Bridge raising project. This development is an extraordinary engineering feat located over the Kill-Van-Kull Strait, connecting Staten Island, New York to Bayonne, New Jersey. This project was initiated to address the critical need for modern cargo ships to access the ports of Newark and Elizabeth, New Jersey, which are among the busiest on the eastern seaboard. The original bridge, completed in 1931, had a navigational clearance that was too low for the new generation of ultra-large container vessels introduced with the expansion of the Panama Canal. Completed in 2019, the project successfully raised the bridge's roadway from 151 feet to 215 feet above the water level, while also maintaining the iconic arch design. This adjustment made it possible for ships nearly twice the size of those previously accommodated to pass underneath, significantly increasing the operational capacity and efficiency of the port facilities. The project cost was approximately $1.7 billion, reflecting both its scale and complexity. One of the significant challenges was executing the work without disrupting the heavy vehicular traffic on the bridge, which necessitated innovative construction methods and careful scheduling. In terms of its engineering methodology, the project was notable for its use of the raise the roadway technique. This method involved building a new roadway above the existing one while traffic continued below, and then removing the lower roadway upon completion. Comparing the scale of the Bayonne Bridge project to other engineering projects, its new 215-foot clearance is high enough to accommodate an NFL football field standing on end. The Bayonne Bridge raising faced numerous challenges during its execution, including technical difficulties inherent in working with existing structures, the need to maintain stringent safety standards, and the unpredictable weather conditions over the strait. The project also had to navigate complex regulatory and environmental approvals, coordinating with multiple governmental bodies and community stakeholders to mitigate impacts on the surrounding areas. But what about one of the tallest skyscrapers in New York City? Located in the bustling Hudson Yards district of Manhattan, the Spiral Tower stands as a pinnacle of architectural innovation and modern design. Officially known as 66 Hudson Boulevard, this towering skyscraper reached its completion in 2022, emerging as one of the most distinctive profiles against the Knicks skyline due to its spiraling green terraces that ascend with the building's rise. The spiral spans 65 stories, measuring approximately 141 feet in height. The project carried a substantial financial commitment, with development cost estimated at around $3.7 billion. The construction of the spiral employed approximately 7,600 workers across various phases, reflecting its scale and the complexity of its design. This architectural marvel was conceived to offer a blend of premium office spaces and expansive green outdoor terraces on each floor, integrating nature into the urban workspace. Each terrace is equipped with foliage and seating areas, providing accessible outdoor space to office occupants, a rare feature in Manhattan's dense urban landscape. The construction of the spiral involved innovative building techniques, particularly in the integration of its steel superstructure with the cascading terraces. Advanced computer modeling and precision fabrication were crucial to ensuring that each floor's outdoor space seamlessly aligns with the spiraling design. The spiral's total floor area is about 2.8 million square feet, roughly equivalent to the size of 50 football fields. However, the project wasn't without challenges. Its construction phase coincided with a pandemic, which posed significant logistical challenges, delaying materials and reducing workforce efficiency due to health and safety protocols. Yet, the project team adapted with enhanced safety measures and scheduling adjustments to mitigate these impacts. Up next, it's time to investigate the Goethals Bridge. This project is a significant architectural feat in the United States, linking Elizabeth, New Jersey, to Staten Island, New York. The bridge was originally constructed in 1928 and underwent a massive rebuilding project that began in 2014 and concluded with the opening of its eastbound span in 2018. The total project cost was approximately $1.5 billion, highlighting its scope and the investment required to modernize critical infrastructure. Designed to replace an aging structure that could no longer efficiently handle modern traffic volumes, the new Goethals Bridge features twin spans, each supporting 3 lanes of traffic, additional shoulders, and a pedestrian and bike pathway that will be completed in a future project phase. One of the most notable methods used was the modular construction approach. Large segments of the bridge were prefabricated off-site and then transported to the location for assembly. This method not only sped up the construction process, but also minimized environmental impact and disruption to the existing traffic. The Goethals Bridge project was a technical challenge, involving the installation of 60-foot tall piers and the lifting of massive 900-ton segments into place. The bridge spans a total length of 1.4 miles, with each of the twin spans stretching approximately 900 feet in their longest span section, requiring precision engineering and construction expertise. One unique aspect of the Goethals Bridge is its focus on sustainability. The project included measures to protect the local marine environment and featured the extensive use of recycled materials. Moreover, the bridge's design incorporates energy-efficient LED lighting and has provisions for future smart transportation technologies. Let's travel to Los Angeles for the LAX International Airport Modernization Project. The initiative is slated for completion in 2028 prior to the Olympic Games and is currently one of the most significant infrastructure undertakings in the United States, with a budget exceeding $14 billion. Spanning over 1,700 acres, the airport project aims to accommodate increasing passenger numbers, projected to rise to over 100 million annually by the end of the decade. This extensive modernization includes the construction of new facilities, enhancement of existing structures, and the introduction of innovative transport systems. The project involves the addition of more than 3 million square feet of terminal space, effectively increasing the airport's size by 25%. This addition is equivalent to about 42 football fields laid side by side. The centerpiece of the project, the midfield satellite concourse, alone spans 750,000 square feet, featuring 12 new aircraft gates. Additionally, the project features a centralized utility plant upgrade that employs 6,000 solar panels and an advanced water reclamation system, which together aim to cut energy consumption by up to 25%. Challenges faced during this vast project include maintaining airport operations during construction. Solutions have involved intricate phasing of construction activities and the use of real-time analytics to manage flow and logistics across the sprawling site. We move over to New York next for the Hudson Tunnel project. This massive project aims to construct a new rail tunnel under the Hudson River, directly addressing the critical need for modernized and reliable rail connections between New Jersey and Manhattan. Currently estimated to cost around $11.6 billion, the Hudson Tunnel project involves constructing a new 2-track rail tunnel, refurbishing the existing century-old tunnel, and making related infrastructure improvements. Upon completion in 2026, it is expected to significantly reduce the risk of severe disruptions in daily commutes and national rail transport. The new tunnel's construction is a complex challenge, requiring sophisticated tunnel boring and under-river drilling techniques to navigate the geological and environmental sensitivities of the Hudson River's underwater terrain. The existing North River Tunnel, which currently serves as the only rail link under the Hudson for Amtrak and New Jersey Transit trains, has been in service since 1910 and was severely damaged during Hurricane Sandy in 2012. The construction of the new tunnel will allow this old tunnel to be closed for repairs without disrupting the critical train services it provides. To understand the scale of the Hudson Tunnel project, consider that the new tunnel will extend about 2.5 miles under the riverbed, involving millions of cubic feet of excavated earth enough to fill over 1,000 Olympic-sized swimming pools. The project's challenges are immense, from navigating bureaucratic hurdles and securing funding agreements across multiple government entities to the physical difficulties of urban tunneling. It's time to travel to San Francisco next, where the gigantic Chase Center is one of the city's biggest megaprojects. Located in the Mission Bay neighborhood of the city, Chase Center serves as a state-of-the-art arena primarily for the Golden State Warriors and a versatile venue for concerts and other events. This mega project, completed in September 2019, was a private sector initiative spearheaded by the Warriors' ownership, costing an estimated $1.4 billion. Chase Center covers an area of 11 acres and includes an 18,000-seat arena, 2 office buildings, 100,000 square feet of retail space, and a public plaza. The project also involved the creation of a waterfront park along with a half-mile of restored public waterfront. One of the challenges in its development was integrating the center with San Francisco's existing public transport networks. This led to significant improvements in local infrastructure, including the addition of a Muni Metro light rail platform and the enhancement of nearby roads. The use of cutting-edge seismic technology was a focal point, considering San Francisco's susceptibility to earthquakes. This included innovative base isolators and shock absorbers that ensure the arena can withstand significant seismic events. Chase Center's unique architectural design and construction methods included the use of sweeping glass facades and intricate metalwork that complements the bay's maritime setting. If you consider the height of the arena at nearly 135 feet, it stands tall enough to house the Statue of Liberty inside it, giving a sense of the scale at which this construction was conceptualized and executed. It's time to move over to Boston now for the Green Line Extension Megaproject. This extension aims to enhance public transit services by connecting the densely populated but underserved areas of Somerville and Medford to the existing subway network, thereby increasing accessibility to central Boston. Launched with major construction efforts ramping up around 2018, the GLX project completed in 2023. The project's budget, initially estimated at $2 billion, saw an increase to nearly $2.3 billion due to unforeseen construction and environmental challenges. Spanning approximately 4.7 miles, the GLX adds 7 new stations along 2 branches, one terminating at Union Square in Somerville and the other at Tufts University in Medford. These new tracks and stations are expected to serve about 45,000 riders daily, significantly easing traffic congestion and reducing commute times in these high-density corridors. The workforce required for this mammoth project varied throughout its phases, involving up to 1,000 construction workers and engineers at peak times. One of the most critical problems the GLX project addresses is the reduction of vehicle emissions by providing a reliable and efficient public transit alternative, thereby contributing to the state's environmental goals. In terms of construction, the GLX employed advanced methods, including the use of track-laying machines that allowed for faster, more efficient installation of rail lines. This project also involves substantial upgrades to existing infrastructure, such as the improvement of bridges and roads along the extension path, ensuring that the new service would be integrated smoothly with minimal disruption. Challenges encountered during the GLX project included managing complex logistics in densely populated areas, mitigating noise and disruption to local communities, and addressing cost overruns and delays, which were exacerbated by the pandemic. But what about a massive dam megaproject? For that, we have to travel to the Ohio River, where the Olmsted Locks and Dam project is located. This monumental undertaking, designed to replace aging infrastructure and modernize the waterway system, is crucial for the transportation of billions of dollars worth of goods annually across central states. This project, which officially completed in 2018 after over 30 years of planning and construction, spans across the river and involved an extraordinary financial investment of approximately $3 billion. The construction required the sustained effort of hundreds of engineers, technicians, and laborers over several decades, underscoring the project's scale and complexity. The Olmsted project replaced 2 older and less efficient facilities, locks and dams 52 and 53, which had become increasingly unreliable, causing significant delays in river traffic and logistical inefficiencies. The new structure consists of a navigational pass and 2 parallel 110-foot by 200-foot locks. This setup significantly eases the river traffic, allowing for the smooth passage of approximately 90 million tons of cargo yearly. One of the notable challenges of the Olmsted Locks and Dam was its innovative construction method, specifically the use of in-the-wet technology. Unlike traditional dry dock methods, this technique involves assembling large modular sections of the dam on land, then floating them to their installation site on the river. The total amount of concrete used in the dam's construction would be enough to pave a sidewalk stretching from New York to San Francisco. A special feature of the Olmsted Locks and Dam is its resilience to seismic activity. The region is near the New Madrid fault line, and as such, the structure was designed to withstand significant earthquakes, ensuring the long-term stability and safety of this critical infrastructure. The project's importance extends beyond just its immediate functionality. By improving the reliability and efficiency of the Ohio River as a navigational channel, the Olmsted Locks and Dam also bolsters the economic viability of river transportation, which is significantly more fuel-efficient and environmentally friendly compared to road and rail transport. Moving over to Chicago, we have to talk about the Lincoln Yards Megaproject. This expansive plan, spearheaded by Sterling Bay, is a $6 billion redevelopment plan that is reshaping over 55 acres of former industrial land into a vibrant, mixed-use complex. Upon its phased completion, with projections spanning the next decade, Lincoln Yards aims to serve as a new epicenter for residential living, commercial activity, and cultural flourish in Chicago. A pivotal element of Lincoln Yards is its promise to create upwards of 24,000 full-time jobs during its construction phases, involving a vast array of trades and specialties. At its core, Lincoln Yards is designed to address the pressing need for urban revitalization and connectivity between Chicago's northwestern neighborhoods, effectively bridging a gap that has long segmented the city. The development encompasses over 14 million square feet of buildings, including high-rise residential towers, office buildings, and an array of retail spaces. One of the major challenges Lincoln Yards faces is integrating this vast new development seamlessly with existing infrastructure. The plan includes substantial improvements to local transit systems and roadways, including a new metro train station, multiple new bridges over the Chicago River, and enhanced pedestrian and bike paths to ensure accessibility and reduce traffic congestion. An ambitious aspect of the Lincoln Yards project is the proposed Live Nation Entertainment District, which will include multiple venues for concerts and cultural events, capable of hosting thousands of visitors. This entertainment component is envisioned to be comparable in scale to London's O2 Arena District, albeit integrated within a larger mixed-use development. It's time to travel to the state of Texas, where Tesla's Gigafactory is located. This sprawling facility, initiated in July 2020, underscores Tesla's commitment to scaling up its production capabilities, particularly for the Tesla Cybertruck, Model Y, Model 3, and Tesla Semi. Occupying over 2,500 acres along the Colorado River, Giga Texas is designed to be an eco-friendly facility, integrating closely with the surrounding environment. The site is one of the largest buildings in the world by footprint, featuring approximately 10 million square feet of operational space spread over several floors. This size equates to about 172 football fields, providing a visual of the vast scale of this project. The total investment by Tesla into this project is expected to exceed $1 billion, which is anticipated to inject significant economic activity into the local and state economy through direct employment and ancillary benefits to suppliers and service providers. Giga Texas is pivotal in solving the logistical challenges associated with Tesla's supply chain, aimed at reducing shipping costs and production bottlenecks. It is set to become a critical hub for Tesla's operations in the eastern United States, enhancing the company's distribution logistics across the East Coast and international markets. The factory's location was strategically chosen for its proximity to rail and road networks, facilitating efficient material shipments and distribution of finished vehicles. But what about the redevelopment of an entire train station? That's what happened with New York's Moynihan Train Hall. This grand project, completed in January 2021, seamlessly blends state-of-the-art facilities with historic architectural elements. The project cost approximately $1.6 billion, a strategic investment aimed at reviving the Midtown area and providing New York commuters and travelers with a more dignified and spacious environment. Construction of the train hall was a logistical challenge, requiring the coordination of thousands of workers in a densely populated urban area. The workforce fluctuated throughout the project, peaking at around 1,200 workers during its most intense phases. These individuals were involved in intricate tasks ranging from restoring the century-old steel trusses to integrating modern technology and security systems within the structure. The Moynihan Train Hall solves several pressing problems associated with the original Penn Station: overcrowding, lack of natural light, and limited amenities. By expanding into the Farley Building, the project has effectively increased the station's total footprint, allowing it to serve up to 700,000 passengers daily. The hall's design features a dramatic 92-foot-high skylight that arches over the main concourse. This skylight, covering an area of 31,000 square feet, not only illuminates the space with natural light, but also serves as a modern counterpoint to the Farley Building's Beaux Arts facade. But how about an entire stadium being replaced? The Aloha Stadium Replacement Project, located in Halawa, Hawaii, is a significant undertaking aimed at revitalizing the sports and entertainment capabilities of Hawaii's most populous island, Oahu. This ambitious project replaces the aging Aloha Stadium, originally built in 1975, which had become increasingly costly to maintain and no longer met modern safety or functionality standards. Scheduled for completion in 2028, the new stadium complex is anticipated to cost over $350 million. The project covers an extensive area of approximately 98 acres, with the new stadium expected to seat around 35,000 spectators, down from the old stadium's capacity, but designed to offer improved sightlines and amenities. This size makes it comparable to the StubHub Center in California, though with enhanced technological integrations. Employing around 2,000 workers during peak construction phases, the project faces the unique challenges of building in an island setting, such as logistics complications related to material shipping and the high cost of labor and supplies in Hawaii. The new stadium will employ modern construction techniques, including the use of sustainable materials and energy-efficient designs to minimize its environmental footprint. Features like solar power generation and water reclamation systems are planned to make it one of the greenest stadiums in the nation. A key problem that the new Aloha Stadium aims to solve is the economic inefficiency of its predecessor. The old stadium was underutilized, partially due to its deteriorating condition and lack of modern facilities that limited event hosting capabilities. The new complex, with its state-of-the-art features, seeks to attract more high-profile events and consequently generate significant economic benefits for the region. One innovative aspect of the project is its integrated approach to development. The stadium complex will include mixed-use developments such as hotels, retail spaces, and residential areas, creating a vibrant community hub rather than just a sports venue. This model follows the trend seen in projects like the Atlanta Braves' Truist Park, which integrates a stadium with a larger commercial and residential district. We have to talk about the 2nd Avenue Subway Megaproject next, located in New York City. Officially part of the Metropolitan Transportation Authority network, this new subway line runs along 2nd Avenue on the east side of Manhattan. The project has been in the conceptual and developmental stages since 1920, but saw its first phase completed and opened to the public on January 1, 2017. Phase 1 of the 2nd Avenue subway cost approximately $4.45 billion and included 3 new stations with a new terminal at 96th Street. The construction of the 2nd Avenue subway involved approximately 6,000 workers at various stages, tackling complex urban engineering challenges such as tunneling beneath densely populated areas and avoiding disruptions to the existing utility infrastructures. This necessitated the use of tunnel boring machines, which are sophisticated pieces of equipment that can efficiently cut through New York's bedrock while minimizing vibrations that could damage building foundations above. The 2nd Avenue subway covers a planned total length of 8.5 miles once all phases are complete. To put the scale of this project into perspective, the total length of the new subway line would be equivalent to more than 146 football fields laid end to end. Each station is built with expansive, column-free platforms and high ceilings to enhance passenger comfort and safety, a notable departure from many of the city's older subway stations. The 2nd Avenue subway has faced numerous challenges, including budget overruns and delays, primarily due to the complexities of constructing a new subway line in one of the world's most built-up urban environments. Comparatively, the cost and scope of the 2nd Avenue subway are similar to those of the Crossrail project in London, although the latter is even larger in scale. Next up, we have to talk about the Atlanta Beltline project. Envisioned as a comprehensive revitalization effort, the Beltline aims to convert a historic 22-mile railroad corridor encircling downtown Atlanta into a multi-use trail, modern streetcar line, and expansive green space. This grand project, which began in the early 2000s and is expected to continue in phases through 2030, is not only redefining urban transit, but also enhancing community connectivity. With an estimated cost exceeding $4.8 billion, the Atlanta Beltline is one of the largest, most wide-ranging urban redevelopment projects in the United States. It involves the coordination of multiple city departments and private contractors, engaging thousands of workers over its multiple phases of development. The Beltline addresses several critical urban challenges, including the need for improved public transportation options. By connecting 45 in-town neighborhoods with multi-use trails and transit options, it promotes a more sustainable lifestyle, reducing reliance on automobiles and encouraging walking, biking, and public transit. A notable feature of the Atlanta Beltline is its use of existing railroad tracks for the trail and transit system. The incorporation of art installations in parks along the Beltline has also turned previously neglected spaces into vibrant public areas that foster community interaction and cultural expression. The project has faced challenges, particularly in terms of funding and community engagement. Balancing the diverse needs and expectations of various stakeholders, residents, and city officials has required continuous dialogue and adaptation. Let's travel over to North Carolina, where the Charlotte Gateway Station is being constructed. This significant development, a central hub designed to integrate various modes of transportation, including Amtrak, buses, and future light rail services, is part of a larger vision to improve transit connectivity across the region. Scheduled for full operational status by 2025, the Charlotte Gateway Station began its early phases in 2018 with a budget projected to exceed $800 million by the project's conclusion. The station itself will cover several city blocks, featuring a state-of-the-art passenger terminal, bus bays, and extensive parking facilities. The project's total area is comparable to 20 football fields, emphasizing its scale and the transformational impact on the city landscape. It is expected to serve thousands of passengers daily, significantly easing the city's traffic congestion and providing a more efficient, reliable public transportation network. One of the primary challenges has been coordinating the multiple phases of construction while minimizing disruptions to the existing traffic and businesses in downtown Charlotte. The station's design features include expansive glass facades to maximize natural lighting and open public spaces that encourage pedestrian traffic, reflecting new trends in urban station aesthetics and functionality. In comparison to other transportation projects like the Moynihan Train Hall in New York City, the Charlotte Gateway Station is unique in its incorporation of green building practices and its role in catalyzing economic development in a mid-sized American city. Despite challenges such as budget adjustments and the complex logistics of constructing in a dense urban core, the Charlotte Gateway Station is set to become a critical node in North Carolina's transportation network.
The Texas Seawall, also known as the Ike Dike, is a majestic coastline infrastructure project intended to protect the Houston-Galveston region from destructive hurricanes and sea storm surges. The project was inspired after the hurricane in 2008 caused massive destruction. The infrastructure giant is a smooth blend of engineering skills and environment preservation. The seawall runs along a length of 70 miles, having a combination of levees, gates, and dunes that act as a united shield against the rough sea tides. The project also includes massive floodgates that are helpful in preventing the storm surges to enter vulnerable areas around the Galveston Bay. The Texas Seawall features a naturally inclusive design with the incorporation of restored wetlands and dunes to alleviate the impact on the environment. Establishing natural elements like wetlands and dunes helps the man-made barriers from giving in to nature's tools and saves them from erosion and wearing away. Aligning the ecosystems with the project's goals makes it easier to make the environment safe and enables a suitable habitat for animals and greenery to thrive. A plush touch of modern technology makes the project an innovation for the architectural world. The technology includes storm surge models that deal with the course of the flood-driven water. Moreover, the design itself is very flexible, making it easier for it to adapt and adjust to all kinds of climatic changes the region may experience in the future. The components used in the project may be added or removed if needed, ensuring a better working model without disrupting the whole system. The project has the tendency to adapt to potential changes in natural or artificial factors, like population growth and drastic changes in climate. Since the model is based upon standardized modules, it is easier to look after and maintain it using custom-made parts without affecting the efficiency of the system. Federal grants, the contributions done by the state, and public-private partnerships have all unitedly secured an estimated budget of $26 billion to $31 billion. The Texas seawall is a resilient project made to protect civilians and expensive infrastructure from being ruined and destroyed by hurricanes and floods. The restoration of wetlands promotes a sense of biodiversity, which is an important aspect for preserving the ecosystem and protecting it. Even though the Texas seawall is a game changer for the modern world's assets, it has some disadvantages too. The cost itself is a huge question mark for the funds and economy of the state. The amount of time required to complete such a mega project could pose a threat to the areas vulnerable to hurricanes and storm surges. And even though the project is sworn to protect the ecosystem, it is bound to destroy coastal and marine habitats due to its massive construction scale. Despite its cons, the project is a necessity, given the fact that the Gulf Coast is one of the regions in the US that is most prone to hurricanes. The threats and losses caused by hurricanes like Hurricane Harvey emphasize the significance and need for a strong, resilient barrier against these natural disasters. Once it is completed, this Texas seawall will stand to become a global benchmarking standard for storm surge protection as an intersection of engineering with ecology, ensuring safety even as it fosters the sustenance of one of America's most vital coastlines along it. Aimed to modernize the aging Interstate 70 corridor, the Central 70 project is a transformative infrastructure endeavor in Denver, Colorado. The project intends to improve efficiency in transportation, safety, and urban connectivity while also addressing community and environmental concerns. This project includes the expansion of the highway, which will be done by reconstructing a 10-mile expansion in Interstate 70, stretching from Brighton Boulevard all the way to Chamber Roads. An express line will also be added in each direction to relieve the traffic flow from either side. The layout plan also features a park landscaped over 4 acres, which will be built over a designated part of the highway, intended for creating a community space to reduce the noise from the roadway. The park will hold playgrounds, recreational spaces, and areas for community events. The project pays extra attention towards the preservation of the environment and improved air quality through modern vehicle emissions and urban greenery. It also features an upgraded stormwater management system, which will prove helpful in reducing the risk of floods in the future. The best part about Central 70 is that it integrates the intelligent transportation system in the highway's maintenance, which includes real-time traffic monitoring and dynamic lane management systems. Central 70 is estimated to cost $1.2 billion, which will be managed by funds from federal and state grants, private investments, and toll revenue collected from the express lanes. The completion of this plan will resolve a lot of issues. It will enhance the mobility of the region's traffic and help ease the traffic congestion, saving people's time and making their commute easy. The modernized structure of the highway will follow the safety protocols and promote the prevention of accidents and risky situations. While this huge expansion can be a game changer for the areas in question, it can cause some problems too. The cost allocated for the completion of this project is too high and could cause a strain on the budget, while the ongoing construction has caused discomfort to civilians in the form of detours and delays. Some worry that the upgrades could lead to a hike in nearby property values and displace long-term residents. The Interstate 70 corridor is one of the most important modifications for Denver's economy and mobility, but has long suffered from aging infrastructure, congestion, and neighborhood divisions. The project will modernize the highway while fostering urban revitalization and addressing community needs. The Nevada Electric semi-truck manufacturing plant will profoundly alter the landscape of logistics and freight in America, as it mass produces emission-reducing electric freight semi-trucks that operate in a business generally well known for its immense negative environmental footprint. Sited in Nevada, this is all part of the effort done elsewhere, specifically at Manteno, in producing advanced lithium battery production vital to the motive power that is not only for electric vehicles, but also massive freight trucks. The plant covers an area of 100 acres in Nevada. The facility is supposed to consist of several buildings that include testing facilities, support structures, and assembly lines. The layout designed for the facility includes gigantic warehouses for storing raw materials like lithium-ion battery cells and robotic arms for assembly purposes. The electric semi-trucks will prove to be tough rivals for diesel trucks because of their long-range capabilities and luxurious features like high-efficiency motors, advanced battery management systems, and lightweight materials showcasing their improved performance. By incorporating the usage of renewable energy sources, the Nevada facility will give wings to the goal of promoting green energy. The plant will facilitate its energy sources primarily through solar power. Talking about eco-friendly features, waste and emissions from the manufacturing process will be minimized through strategic recycling programs and energy-efficient systems. The factory will also prefer electric power over fossil fuels to reduce its own carbon footprint and unnecessary emissions of harmful waste. In conclusion, the Nevada Electric Semi-Truck Manufacturing Plant aims to be a manufacturer and an example of green, sustainable practice by industries. It will contribute, thereby, to the larger transition in regards to sustainable transportation by fulfilling a great need for transportation, for electrifying the freight industry in an economy. But what if I told you that we have only just started? The Brent Spence Bridge Corridor project is a masterpiece of the architectural world. The bridge works as a corridor that connects Cincinnati, Ohio, and Covington, Kentucky. The Brent Spence Bridge is an important and transformative infrastructure that is vital to easing traffic congestion and modernizing freight and transportation routes between the connecting cities. The project is based on constructing another bridge alongside the already standing Brent Spence Bridge. The extension will help separate traffic lanes for smooth travel, increasing the efficiency and safety of civilians. This project is designed in a way that thoroughly supports green space and small commercial developments around the area by having the feature of enhanced decks over I-75. However, the Brent Spence Bridge is an expensive architectural venture that has an estimated budget of $3.6 billion after increasing from $2.5 billion. It is fully funded by the federal and state authorities of Ohio and Kentucky. The budget was allocated by keeping the factors of progressive design-build strategies and regional and national needs in mind. The project brings forth several benefits along with it. The enhanced safety features, like traffic divergence, ensure the minimization of accidents and critical mishaps. The project supports economic growth in the whole region by supporting smooth freight transport throughout, while also aiming to revitalize the adjacent areas with new local roads and green spaces. Although the mega project of this bridge is a fruitful one, it does have its cons. With such a huge project underway, the local communities may face difficulty because of detouring and construction delays. Since the project is costly, the state might compromise local resources, which is not good news for civilians. The Brent Spence Bridge calls for the urgency of a most wanted infrastructural design that will deal with freight and transportation on one of the busiest corridors of the United States. Even though infrastructure is important for the stability of the economy and revitalization, it is also considered important to freshen the mind and soul a bit. The Sound Transit 3 is an ambiguous and innovative effort toward expanding public transportation networks across the Puget Sound region. Since Seattle is facing rapid population growth, the need for efficient and sustainable transportation has grown inevitable. ST3 aims to relieve various problems, like congestion, reduction of the emission of greenhouse gases, increase the accessibility of the transit network in the region and improve mobility. The main target of the project is the expansion of the Sound Transit light rail system, which will be extended to almost 62 miles. New railway lines will be laid from the downtown core of Seattle to some suburban areas like Redmond, South Kirkland, Linwood, and Ballard. The expansion will lead to the creation of 30 more stations, which will provide citizens with economic, cultural, and transportation hubs, and ensure a reliable and frequent mode of service. In addition to the rail network, the project also focuses on introducing new BRT systems, which will redefine connectivity in the region. The BRT systems will connect faraway regions that won't have access to light rail facilities due to excessive distance. This addition will enable a flexible mode of transit and make sure that people living in more remote parts of the region have the opportunity to avail public transportation to its fullest without unnecessary delays. The ST3 project secures a key part in the environmental strategies of Seattle. The increased chance to adopt public transportation will help people get rid of traveling through vehicles like cars and bikes, and reduce the irregular congestion typically caused by too many vehicles. The plan smoothly aligns with the region's goal of net zero emissions by 2050 and promotes health and safety since the light rail is specifically designed to run on green energy. ST3 is estimated to have a huge budget of $54 billion. The massive funding required to do so will be driven by an increase in sales tax approved by voters in 2016. The remaining budget will come from the joint contribution of federal grants, bonds, and loans, as well as funds from state and local governments. As plush as it sounds, the project will cost the state a lot more than money. The hefty price of the project will increase the political pressure and will be the reason for problems like the rise in construction costs and the potential delays that will accompany its completion. The Manteno EV lithium battery manufacturing plant is another major development that intends to modernize and green the industries. The growth of sustainable transportation does not only apply to the public transportation sector, but also goes down to the manufacturing sector. It includes areas such as electric vehicle production and battery development. The colossal manufacturing plant will cover over 150 acres of land and will focus on the production of lithium-ion batteries for electric vehicles. The Manteno EV lithium battery manufacturing plant is estimated to cost around $4 billion. This investment will support the facility's extensive infrastructure, including high-tech manufacturing lines and clean energy systems. The facility will be equipped with multiple high-tech production lines, which will produce a substantial number of 40,000 megawatt-hours of batteries annually. To ensure a smooth production process, the incorporation of advanced automation and robotics will prove worthy. The facility will house multiple manufacturing buildings, warehouses, and research and development areas. The plant is designed to maximize the efficiency of the manufacturing process, with separate areas for battery production, testing, and quality control. Since the plan aligns with the goal of keeping the environment clean and preserved, the plant will be powered by renewable energy sources for secure green manufacturing. The Manteno facility strictly incorporates recycling trends and programs to reduce waste and provide a sustainable core to the project. This project will greatly reduce the US's reliance on foreign sources like lithium for electric vehicle batteries. The green tech sectors, manufacturing department, and logistics will create hundreds of thousands of employment opportunities for individuals. Furthermore, the plant will boost the economy of Illinois by improving its position and making it a leader in the sector of clean energy. We've talked about transit through ground, but shouldn't there be some kind of project for transiting through air too? Well, actually there is. As Texas paves the way for seamless urban transit, Chicago takes it up a notch and introduces a new project regarding air transit, and it's known as the Chicago O'Hare Airport Upgrade. This project is as big as a plane, and the budget allocated for it touches the sky too. $8.5 billion. Chicago O'Hare is one of the busiest airports in the United States. It is currently undergoing an expensive transformation to provide its passengers with an enhanced experience and increase the operational efficiency of the airport. The upgrade is called the O'Hare 21 project, which is supposed to maintain Chicago's status as an international transit hub. The O'Hare project's main highlight is the O'Hare Global Terminal, a state-of-the-art facility that is to replace Terminal 2. This upgrade will integrate international and domestic flights, offering smooth connection between flights and increased capacity for airplanes. The renovations and expansion of Terminals 1, 3, and 5 will have the newly added features of updated gates, lounges, and luxuries to make the people comfortable during long stays and waiting. The technology enhancement included in this project is the most modern upgrade for the airport. The old baggage handling systems are replaced with new ones with automated check-in to ensure a smooth and safe transition, and advanced security are part of the upgrade. Just like any other project, the O'Hare project also prioritizes an eco-friendly environment over anything. To make sure energy-efficient designs, natural lighting, and eco-friendly materials are used over other options. To ensure a smooth transit and flow of passengers, 25 new gates will be added. This will reduce any delays and accommodate larger aircraft at a time. More gates will minimize bottlenecks. These upgrades are bound to make the airport capable of handling 25% more passengers, which would ease up the congestion. Improved terminals will let the passengers enjoy a lavish experience, loaded with perks like world-class dining, shopping, and waiting areas. The construction period and increased workload will generate high-paying jobs, which will stimulate economic growth and increase tourism and business travel. O'Hare is a critical spot in the world of aviation and struggles with the problems faced because of aging infrastructure and rising public demands. The upgrade addresses these challenges. Once the renovations are finished, O'Hare might just prove to be an even tougher competition for other global hubs like Dubai and Singapore. O'Hare 21 project sets a new blueprint for the future of global aviation by motivating other states to invest in aviation and make the quality of their services better and more comfortable. Amazon HQ2 is the second headquarters of the global e-commerce mammoth. It is located in Arlington, Virginia. The fact that Amazon has this project up its sleeves reflects Amazon's innovation, dedication, and economic stability. These huge headquarters span over 4 million square feet, covering several state-of-the-art office buildings. The headquarters centerpiece, known as the Helix, is a beautiful spiral structure made mainly of glass that embodies vegetation patches and green spaces. A walk through the campus is like exploring a small town. The facility features public parks, retail outlets, and amphitheaters for public events. These just make it more fun than just a workspace. The infrastructure prioritizes an eco-friendly environment. The buildings surrounding the facility promote net zero carbon. The whole headquarters is equipped with advanced energy-saving systems. Amazon HQ2 uses smart technology for smooth operations and convenience for its employees. The budget for making it a reality is projected to exceed $2.5 billion. But this huge amount is overshadowed by the company's dedication and promise to create a flagship facility that is supportive to its workforce and local economy. Amazon HQ2's construction has a promising future for everyone. The facility is expected to generate 25,000 high-paying jobs, which attracts talented folks from all over the globe. With it being an economic generator, Amazon HQ2 is anticipated to contribute an annual sum of $4 billion to the economy. The project's standards ensure a bright future for the development of green spaces as it focuses on features like renewable energy integration. Amazon HQ2 is a promising project, but it has some potential drawbacks too. The most concerning thing is the region's reliance on Amazon. If the company tends to shift its priorities in the future, the economic situation could go for a downfall. Opening an expansive facility in an already busy area means gridlock and stuffiness. The surrounding area could face a difficult situation if there isn't a solution for the traffic problem. The question is, why was Arlington deemed the perfect place to establish Amazon HQ2? Arlington is found to have a robust infrastructure and has access to an educated number of people. The city is also close to Washington, D.C. The location aligns with Amazon's goals, which are to be the best technologically advanced with an influential hold in a key metropolitan area. Amazon HQ2 tends to make Arlington a hub for innovative implementations. Its focus on the community's preferences and sustainability will surely serve as a model for future corporations and developments. Amazon HQ2 demonstrates that economic progress and environmental responsibility can coexist. Talking about environmental responsibility, transportation is a key feature of every region's economic progress and stability. And the US government is working on a project related to that as well. Rooting in Austin, Texas, Project Connect Texas is an immensely innovative mega project that is intended for the transit plan of controlling traffic congestion due to the overgrowing population. Spearheaded by Capital Metro, this project intends to reduce travel time for people and improve accessibility and sustainability. This project is much more interesting than it sounds, and pretty detailed too. It features a bunch of features that would be really helpful in daily life. The project includes a new light rail system, which will cover major areas in Austin. This system will have two lines, the Orange Line and the Blue Line, each of which will allow links to downtown and transit hubs. The project intends to enhance the already existing Red Line and features another addition to the Green Line to expand regional coverage. The Bus Rapid Transit, aka BRT, will have high-capacity corridors to complement the rail lines with sustainability and reliability. The ease of ample parking space in stations would allow the travelers to complete their journey easily. Commuters from suburban areas would surely consider it a heavenly feature. The modern ticketing system will enhance the processing and increase the speed, accompanied by eco-friendly buses that will ensure the safety of the environment. The budget of Project Connect Texas is allocated to be $7.1 billion, which is a joint contribution of federal grants, local taxes, and public-private partnerships approved by Austin voters in a 2020 referendum. The benefits of this project revolve mainly around the economic growth of the region, equity and accessibility, sustainability, and, most important of all, reduced traffic congestion. The project idealizes low-emission transit, which is important if the goal is to save the environment. The only problems that could appear as an obstacle in the project's way are the high costs involved in the construction, long-term construction, which could cause potential inconvenience, ridership projections, and, of course, the problem with land acquisition. But why spend so much to enhance something that already exists? The answer would be the increasing population of the place and the challenges and difficulties that come with a factor like that. Project Connect lays a sustainable and promising groundwork to ensure that most of the commute problems are solved. Completing a big project could inspire smaller projects in smaller and overlooked areas. Let's head to the Strip of Las Vegas, where the track for the 2025 Las Vegas Grand Prix is being set up. The tenants of Las Vegas and F1 fans all around the globe radiate with excitement as the preparations undergo. Taking place in the vibrant heart of Las Vegas, the race will surely be a breathtaking sight to see. The 3.8-mile street circuit, loaded with neon lights, is designed for the drivers to zoom through gorgeous landmarks at a speed of almost 217 miles per hour. Night racing will surely be a stunning visual for everyone to witness the majestic game in its full bloom. The racers will have to burn their car tires for about 192.6 miles over 50 laps. The circuit has 17 turning points for the racers to take advantage of every chance to overtake their competitors. For the same reason, 2 DRS zones have also been designed so that the racers have ample time to overtake and make strategic moves while they're at it. The event organizers sure didn't hold back this time. The event offers a whole lot of luxuries as the event rolls around the corner. Formula One fans can have the craziest experience of their life, as the packages offered in the grand event vary from $500 for general tickets to the maximum amount of up to $5,000 for premium tickets. The event also offers a 3-day pass worth $1,617. The central hub for entertainment will be the T-Mobile Zone. At Sphere will be the host featuring performances by top artists of the world and quintessential Las Vegas shows like Cirque du Soleil. As extravagant as it sounds, the premium packages will allow the people to enjoy VIP services ranging from deluxe amenities, lavish spots for premium views, and plush hospitality from services. The whole experience will be much more than just a race. Beyond the race, fans can look forward to immersive activities like having a personal chef and being served food made by world-class chefs. There will also be live entertainment sessions, and fans will have access to the F1 Paddock Club and even the chance to take a spin in an F1 car. The extravagance of the event screams of the budget itself. And it's true, the budget allocated for it is way higher than anyone can even imagine. The projected scale of the event goes around an estimated amount of hundreds of millions of dollars, all to ensure the brilliance and perfection of logistics, safety, and most significantly, infrastructure. The mixed collaboration of sponsors and organizers like Liberty Media, local government, and private stakeholders is a joint effort towards the promotion of positivity, cultural importance, and economic stability.
But we have to talk about a gigantic station megaproject next. Miami Central Station, strategically situated in the heart of downtown Miami, Florida, is a transformative infrastructure and transit development that epitomizes the future of urban transportation in the southeastern United States. Officially opened in 2018, this expansive multimodal hub integrates commuter rail, intercity rail, and future high-speed rail, forging a new standard for transit connectivity in the region. The project, which is part of the broader Miami Intermodal Center, required an investment of over $2 billion and brought together a wide array of transportation systems under one roof. Miami Central not only serves as a vital junction point for Brightline services connecting Miami with Fort Lauderdale and West Palm Beach, but also accommodates Metrorail and Tri-Rail services, facilitating seamless travel across multiple transit lines. Spanning several city blocks, Miami Central Station is designed with a sleek, modern aesthetic that incorporates state-of-the-art architectural elements. One of the most significant challenges during the construction was integrating the new facilities with existing transit services while minimizing disruption to daily commuters. This involved careful planning and phased construction strategies, including the strategic placement of platforms and the careful coordination of numerous construction teams working in a densely urbanized area. The station's architectural design required innovative construction techniques to support its complex, multi-level structure. This includes the use of high-strength steel and reinforced concrete capable of supporting heavy rail components and high passenger footfalls, while also withstanding Florida's challenging weather conditions, including the threat of hurricanes. In terms of scale, Miami Central's construction involved moving thousands of tons of earth and laying miles of new track activities comparable to erecting a small city. We have to talk about the Northeast Boundary Tunnel next. This mammoth undertaking, part of the larger Clean Rivers project in Washington, D.C., aims to significantly reduce combined sewer overflows into the Anacostia River, enhancing the river's water quality and complying with federal clean water regulations. The project, which began in 2018, is a critical component in a series of infrastructure improvements designed to modernize the capital's century-old sewer system. Spanning 5 miles in length and located up to 160 feet below ground, The tunnel stretches from the Robert F. Kennedy Stadium to the Rhode Island Avenue NW, with a hefty price tag of approximately $580 million. The construction of the NEPT poses formidable challenges, primarily due to the complexity of drilling a massive tunnel underneath a densely populated urban area. The project utilizes a tunnel boring machine named Chris, a 26-foot diameter behemoth that methodically carves through earth and clay beneath the city. A significant issue the tunnel addresses is the problematic sewer overflow during heavy rainstorms, which historically has led to the pollution of local waterways. The tunnel will capture and store this overflow, transporting it to a treatment facility, thus greatly mitigating the environmental impact and improving the health of the Anacostia River. Throughout the project, DC Water has kept residents informed and involved, addressing concerns ranging from construction noise to local traffic disruptions. Advanced monitoring systems are in place to detect even slight movements of the ground, ensuring that the construction does not affect the integrity of buildings overhead. We travel over to San Francisco next for the redevelopment of their international airport. This expansive project, known as the Airport Development Plan, is set to reshape the airport by enhancing capacity and passenger experience through a series of ambitious construction initiatives. Commenced in 2016 with a strategic plan, the development is budgeted at over $7 billion. One of the cornerstone projects within this expansion is the renovation of Terminal 1, a project that began in 2016 with a budget of approximately $2.4 billion. The terminal's revamp includes the construction of a new boarding area with additional gates, upgraded baggage systems, and new dining and retail spaces. The airport's plans also include the enhancement of airfield safety. These changes are designed to improve the efficiency of aircraft movements on the ground, thereby reducing taxi times and minimizing delays. San Francisco International Airport is also focusing heavily on sustainability, aiming to become one of the world's first zero-net energy airport campuses. Solar panels, energy-efficient buildings, and water conservation systems are integral to this vision. The challenges of executing such a vast project in an active airport environment are immense. Construction teams have had to carefully phase their work to minimize disruption to travelers, manage noise levels, and ensure that airport security is uncompromised. Next up, we have to check out the Federal Way Link extension. Located in Washington State, this significant extension aims to enhance connectivity between the densely populated region south of Seattle, spanning from the Angle Lake Station through Des Moines and into Federal Way. The project, managed by Sound Transit, began construction in 2020 and is slated for completion later into 2024. With a budget of approximately $3.1 billion, the Federal Way Link extension will add 7.8 miles of new track to the existing light rail system, promising to significantly ease traffic congestion. Designing and constructing a light rail extension through heavily urbanized areas presents a variety of challenges. One major hurdle has been the need to integrate new rail lines with existing infrastructure, requiring complex engineering solutions to bridge roads, navigate through dense urban landscapes, and minimize disruption to local communities and ecosystems. Extensive tunneling and elevated track sections are key components of the project, designed to ensure that the rail service is both efficient and minimally invasive. The Federal Way extension will include 3 new stations that are being designed with a focus on accessibility, safety, and integration with other modes of transportation, such as buses and pedestrian pathways. The workforce behind this mega project includes hundreds of engineers, construction workers, and safety inspectors. Their expertise is essential in tackling the technical demands of modern rail construction, from laying tracks that can handle high-speed trains to installing sophisticated signaling and communication systems. Upon its completion, the Federal Way Link extension is expected to serve approximately 40,000 passengers daily by 2035. Let's move over to the next megaproject. Spanning the Hudson River in New York, the Governor Mario M. Cuomo Bridge is a stunning feat of engineering that has reshaped the transportation landscape between Rockland and Westchester counties. Completed in 2018, this impressive structure replaced the aging Tappan Zee Bridge. The project, named after the late New York governor, represents a monumental investment in infrastructure, with a total cost of approximately $4 billion. Constructed over 5 years, the project faced numerous challenges, including maintaining traffic flow on the existing bridge while the new spans were being built parallel to it. The project utilized advanced construction techniques such as floating cranes, one of the largest in the world, known as the I-Lift New York Super Crane, which lifted and placed sections weighing up to 1,200 tons. The bridge stretches approximately 3 miles in length, with each of the twin spans measuring around 1,200 feet at their longest span. These spans are supported by 8 419-foot towers, which are angled outwardly, a design choice that not only provides structural efficiency, but also gives the bridge its visually striking profile. One of the unique aspects of the Cuomo Bridge is its accommodation for various transportation modes. It includes not only 8 traffic lanes, but also a shared-use path for bicycles and pedestrians, featuring 6 scenic overlooks and art installations. In terms of materials, the bridge incorporates more than 220 million pounds of American-made steel and 300,000 cubic yards of concrete. To put the size of the project into perspective, the amount of cable used in the bridge's stay cables could stretch from New York City to Chicago if laid end to end. Special features of the bridge include its resilience to extreme weather conditions, designed to withstand the increasing frequency of severe weather events. It is built with corrosion-resistant steel and concrete to ensure a lifespan of over 100 years, significantly improving on the durability of its predecessor. We have to travel to Chicago for the next megaproject. The Chicago Deep Tunnel Project, formerly known as the Tunnel and Reservoir Plan, is an ambitious civil engineering project designed to address the critical issues of urban flooding and water pollution in the city. Spanning over 100 miles of deep, large-diameter tunnels located up to 300 feet beneath the city, the Deep Tunnel Project is one of the largest and most comprehensive urban water projects in the world. With a total estimated cost projected at $3 billion, one of the primary functions of the tunnel is to capture and store stormwater runoff and sewage that would otherwise overflow into the city's rivers and Lake Michigan during heavy rain events. This system can hold up to 2.3 billion gallons of stormwater, significantly reducing the frequency and severity of water pollution incidents and urban flooding in the region. The construction of the Deep Tunnel Project has been a monumental undertaking. It required the use of massive tunnel boring machines, some of the largest in the world, which have carved out tunnels with diameters ranging from 9 to 33 feet. One of the distinguishing features of the project is the construction of 3 immense reservoirs designed to work in conjunction with the tunnels. The largest of these, the Thornton Composite Reservoir, was completed in 2015 and covers 300 acres, making it one of the largest man-made reservoirs for stormwater management in the world. Its capacity is so vast that it could theoretically hold all the water used to fill over 2,000 Olympic-sized swimming pools. In comparison to other megaprojects, such as the Boston Big Dig or the London Sewer System Upgrade, the Chicago Deep Tunnel Project stands out for its scale and its focus on water management in a densely populated urban setting. Next up, it's time to investigate the Huey P. Long Bridge. Since its original completion in 1935, this bridge has stood as a vital link for both rail and vehicle traffic between the eastern and western halves of the metropolitan New Orleans area. The bridge underwent a massive expansion and renovation project that began in 2006 and concluded in 2013, drastically enhancing its capacity and safety. The project's scale was monumental, with a budget of $1.2 billion, making it one of the largest public works projects in Louisiana's history. This extensive modernization aimed to address the bridge's notorious narrow lanes, which were often seen as a bottleneck for traffic and a hazard for drivers. Originally constructed during the Great Depression as part of a nationwide infrastructure initiative, the Huey P. Long Bridge was named after the famed Louisiana Governor Huey P. Long, who was a major proponent of infrastructure projects. At the time of its initial completion, it was among the longest railroad bridges in the United States, featuring a continuous truss design that was a marvel of that era's engineering capabilities. The renovation project expanded the bridge's width, adding wider traffic lanes that increased the overall width from 18 feet to an impressive 43 feet. This expansion included the installation of new roadways and rail lines, significantly increasing the bridge's traffic capacity and safety. The bridge's elevation was a significant challenge, situated 135 feet above the Mississippi River, which necessitated complex vertical construction techniques. Engineers employed high-strength, lightweight concrete and advanced steel composites to handle the loads and stresses involved with such height and width, ensuring long-term durability against the river's powerful currents and the region's frequent severe weather. The construction work involved around 300,000 cubic yards of concrete, enough to fill 90 Olympic-sized swimming pools. It's time to talk about the construction of Raleigh Union Station. This transformative project, which officially opened its doors in July 2018, represents a major upgrade from the previous Amtrak station. Costing approximately $111.4 million, the Raleigh Union Station was meticulously designed to rejuvenate the warehouse district of downtown Raleigh, providing a multimodal hub that accommodates train, bus, and taxi services under one roof. Spanning a vast area of 26,000 square feet, the station's main building was once a dilapidated steel fabrication plant, which has been artfully transformed into a state-of-the-art facility while retaining historical architectural elements. This adaptive reuse not only preserves a piece of Raleigh's industrial heritage, but also incorporates green building practices, including a rooftop rainwater collection system that underscores the city's commitment to sustainability. The construction of Raleigh Union Station was a complex endeavor, involving numerous challenges ranging from the preservation of the existing historic structure to integrating advanced technological systems. The project team employed innovative construction methods such as seismic retrofitting to ensure the station's durability and safety, all while maintaining the integrity of the original building's rugged, industrial aesthetic. The station features lofty ceilings and a spacious concourse flooded with natural light, creating an inviting atmosphere for the approximately 160,000 passengers it serves annually. Raleigh Union Station is equipped with longer, high-level platforms that accommodate more passengers. But what about the expansion of a massive airport? The O'Hare International Airport expansion is one of the most ambitious airport revitalization efforts in the world. Located in Chicago, Illinois, this massive undertaking aims to propel O'Hare into the future of aviation. With a projected budget of $8.5 billion, this expansion is not just a facelift, but a complete transformation aimed at increasing capacity and improving efficiency. Officially launched in 2019, the O'Hare 21 project is slated for completion in 2028. It includes a major overhaul of Terminal 5, the construction of a new Global Terminal 2, and the addition of 2 new satellite concourses. These improvements will expand terminal space by a staggering 60%, allowing O'Hare to handle the anticipated increase in passenger traffic, which is expected to exceed 100 million passengers annually by the project's completion. The centerpiece of the expansion is the new Global Terminal, designed to be the first of its kind in the United States, which will replace the existing Terminal 2. The terminal will cover approximately 2.2 million square feet, making it one of the largest aviation facilities in the country, roughly equivalent in size to 35 football fields. Construction at one of the busiest airports in the world presents unique challenges, particularly maintaining day-to-day operations while managing massive construction efforts. The project employs over 5,000 workers, utilizing innovative construction methods such as prefabricated materials and modular construction techniques to minimize disruption. These methods not only expedite the building process, but also help manage the logistical complexities of working within an operational airport. The O'Hare expansion will also address some of the airport's long-standing issues, such as congestion both on the tarmac and inside the terminals. By redesigning gate layouts and improving the configuration of taxiways and runways, the project aims to significantly reduce taxi times and delays, thus solving a critical problem that has plagued O'Hare for decades. But what about the construction of a massive train station? Denver Union Station was reopened in 2014 after a comprehensive $540 million redevelopment, and the historic train station has been reimagined into a vibrant, multimodal hub that anchors Denver's thriving transit-oriented development. Originally constructed in 1881, Denver Union Station had fallen into disrepair and underutilization by the late 20th century. The bold revitalization project, which began in earnest in 2010, was spearheaded by a public-private partnership aiming to revitalize the area while preserving its historic charm. The project covered 19.5 acres and involved the integration of light rail, Amtrak, buses, and new pedestrian and bicycle pathways, creating a nexus of connectivity for the city and the region. One of the most compelling aspects of the Union Station project was the creation of an underground bus concourse. This 22-gate facility spans nearly 1,000 feet in length roughly, the length of 3 football fields situated beneath 1.5 acres of public plaza that includes fountains and space for public events. This innovative design successfully separates bus traffic from pedestrian areas, enhancing safety and urban aesthetic. The station itself houses more than 110,000 square feet of mixed-use development, including retail shops, restaurants, and a hotel, which occupy the historic terminal building. The Denver Union Station project's challenge was to integrate seamlessly into the existing urban fabric, preserving historical elements like the station's iconic "Travel by Train" neon sign while introducing cutting-edge infrastructure. Moreover, the project team faced the complex task of coordinating multiple transportation systems in a tight urban core, all while maintaining service for thousands of daily commuters. The economic impact has been profound, with billions of dollars in private investment flowing into the surrounding area since the station's reopening. Next up, it's time to visit the Mackinac Bridge project. Known affectionately as Big Mac or Mighty Mac, this bridge links Michigan's upper and lower peninsulas, thus uniting what nature had divided. Located in Michigan, the Mackinac Bridge was completed in 1957 after 3.5 years of construction, overcoming numerous challenges posed by geography and climate. At the time of its completion, the Mackinac Bridge was the world's longest suspension bridge between anchorages, a title it held for many years. Spanning an impressive total length of about 5 miles, with a central span of 3,800 feet, the bridge was a marvel that required extraordinary engineering prowess and innovation. The construction cost was approximately $100 million, equivalent to nearly $1 billion today. Constructing the Mackinac Bridge was a colossal undertaking involving the coordination of hundreds of workers. The project faced many challenges, including harsh weather conditions that could change swiftly, posing risks to workers and the structural integrity of the emerging bridge. Winter gales and fog were routine obstacles that required innovative solutions, such as heated scaffolds and special gear for workers. One of the most notable aspects of the Mackinac Bridge's construction was the use of pioneering techniques for deep water caisson construction. These massive caissons were sunk to depths of up to 210 feet below the water's surface, a groundbreaking achievement at the time. The bridge's towers, standing at 552 feet above water level, required the transportation and assembly of thousands of tons of steel, sourced from mills across the United States. The Mackinac Bridge greatly simplified travel between the two peninsulas, which previously relied on a ferry service that was often hindered by ice in winter. The total amount of steel used in the bridge, approximately 20 tons, is enough to build nearly 400 tanks. It's time to investigate the Interstate 70 East project next. This ambitious project, stretching 10 miles from Brighton Boulevard to Chambers Road, is designed to modernize and expand one of the busiest and most critical highway corridors in the state. Launched in 2018 and completed in 2022, the project has an estimated cost of $1.2 billion. One of the most groundbreaking aspects of the Interstate 70 East project is the reconstruction of a 1.8-mile segment of the highway that includes lowering the interstate between Brighton and Colorado Boulevards and placing a 4-acre parkland cap over a portion of the lowered interstate. This innovative design not only facilitates connectivity between the divided neighborhoods of Globeville, Elyria, and Swansea, but also adds much-needed green space to the urban environment. The project includes the widening of the interstate to accommodate one new express lane in each direction, enhancing throughput and reducing travel time. The total width of the newly designed segments reaches up to 300 feet, including new service roads and auxiliary lanes designed to improve local traffic flow alongside the interstate traffic. Construction of the Central 70 has involved massive logistical challenges, including the management of around 5,000 daily construction workers and the strategic phasing of demolition and construction to keep the interstate operational throughout the project. But how about a massive interstate megaproject? In the heart of Texas, the North Tarrant Express project stands as a testament to transformative infrastructure innovation. Initiated in 2010 and completed in 2014, this project revolutionized 13.3 miles of Northeast Loop 820, an airport freeway designed to address the burgeoning needs of one of the fastest-growing regions in the United States. The project, costing approximately $2.1 billion, wasn't just about expansion. It was about reimagining mobility. By incorporating managed toll lanes known as Texpress lanes, The North Tarrant Express introduced dynamic pricing to manage traffic flow, a first of its kind in Texas. These lanes adjust prices based on real-time traffic conditions, optimizing roadway usage and drastically reducing congestion. Traditional road expansions of this magnitude typically span decades, yet this project compressed timelines into a mere 4 years of construction, all while keeping the highway open. This feat was achieved through around-the-clock work and an innovative approach to staging and materials handling that minimized disruptions to the daily lives of nearly 200,000 drivers. This immense undertaking required the coordination of thousands of workers, from engineers who redesigned interchanges to support smoother traffic flow to expansive construction teams. The North Tarrant Express implemented several green initiatives, such as using recycled materials for roadbeds and deploying advanced stormwater management systems to protect the region's waterways, setting a new standard for eco-friendly construction practices in large-scale infrastructure projects. Moreover, the economic impact of the North Tarrant Express has been profound. By improving access and reducing travel times, the project has spurred growth in local communities, enhanced property values, and attracted new businesses looking to capitalize on improved logistics and accessibility. Next up, it's time to talk about the Bob Graham Sunshine Skyway Bridge project. Opened in 1987, this bridge is not just a crucial conduit connecting St. Petersburg with Terra Sia, but also a masterpiece of engineering. Spanning a total length of 4.1 miles, with a soaring cable-stayed section that stretches 200 feet between pylons, the Sunshine Skyway Bridge stands as one of the longest cable-stayed concrete bridges in the world. Constructed at a cost of $244 million, it was developed in response to a catastrophic collision in 1980, when the original bridge was struck by a freighter during a storm, causing a portion to collapse. This new bridge was designed to prevent such a disaster from recurring, featuring 430-foot tall pylons and a road deck that rises 193 feet above the water, allowing ample clearance for ships passing underneath, thus significantly mitigating the risk of ship collisions. The design of the Sunshine Skyway Bridge integrates advanced engineering techniques, including the use of high-strength, corrosion-resistant steel and aerodynamic concrete pylons, ensuring durability against harsh marine conditions and the threat of hurricanes. The bridge's cables, if laid end-to-end, could stretch over 300 miles, long enough to reach from Tampa to Key West. The construction process itself was a monumental task, employing over 1,000 workers at its peak. These workers braved the challenging conditions of open water to erect the massive pylons and hang the bridge's 21,000 miles of cable. The project not only demanded precision in execution, but also required innovative solutions to minimize environmental impact. It's time to move over to the Blue Plains Tunnel next. This massive infrastructure project is a critical component of DC Water's Clean Rivers project, aimed at drastically reducing combined sewer overflows into the Anacostia, Potomac Rivers, and Rock Creek. The tunnel, completed in 2015, stretches over 2,400 feet in length and is located up to 160 feet below the city's surface. This tunnel was designed to capture and store sewage and stormwater runoff during heavy rains, redirecting up to 100 million gallons of overflow that would have otherwise spilled into local waterways. The project's total cost was approximately $580 million, making it not only one of the largest environmental projects in the city's history, but also a significant investment in sustainable infrastructure. Constructing such a vast underground structure in an urban environment presented numerous challenges. The project team had to navigate around existing utilities and subway tunnels, requiring precise mapping and innovative tunneling techniques. The tunnel was constructed using a tunnel boring machine named Lady Bird, a massive piece of machinery that excavated the tunnel's path while simultaneously laying reinforced concrete to form the tunnel walls. The scope of the Blue Plains Tunnel can be compared to the length of nearly 80 football fields laid end-to-end. The concrete used in the project would be enough to pave a 2-lane road for several miles. Special features of the Blue Plains Tunnel include its state-of-the-art odor control systems designed to treat air before it is vented to the surface, ensuring that the surrounding neighborhoods are not affected by unpleasant smells. It's time to explore the Kennedy Space Center, a monumental project that stands as a pinnacle of aerospace engineering. Located on Merritt Island, Florida, this iconic facility was established in 1962 and became operational during the height of the space race. The total cost of constructing and developing the Kennedy Space Center is estimated at approximately $2 billion. The Space Center spans 144,000 acres and serves as NASA's primary launch center for human spaceflight. Its construction required the efforts of thousands of engineers, technicians, and laborers working around the clock to bring this ambitious project to fruition. The center's most famous feature is Launch Complex 39, which includes 2 launch pads and the massive Vehicle Assembly Building. The VAB is one of the largest buildings in the world by volume and was designed to assemble the Saturn V rocket, the behemoth that carried astronauts to the moon during the Apollo program. The Kennedy Space Center was not just built for the Apollo missions. It has been instrumental in numerous space endeavors, including the Space Shuttle program and, more recently, SpaceX's commercial crew missions. The facility's infrastructure includes a network of crawler transporters that move rockets from the VAB to the launch pads, a distance of about 3 miles. These crawlers are engineering marvels in their own right, capable of carrying the immense weight of fully assembled rockets. One of the significant challenges faced during the construction of the Kennedy Space Center was managing the environmental impact on the surrounding Merritt Island National Wildlife Refuge. This required careful planning and innovative solutions to ensure that the center's operations did not adversely affect the local ecosystem. To understand the scale of the Kennedy Space Center, consider that its launch pads and support facilities occupy an area equivalent to about 219 football fields. The center has continuously evolved, incorporating cutting-edge technology and infrastructure to support the ever-advancing field of space exploration. Next up, let's delve into the monumental Houston Metrorail expansion project, a $7.5 billion undertaking that aims to revolutionize public transit in Houston, Texas. Spanning an impressive 20 miles of additional track, the Metrorail expansion is designed to connect more neighborhoods and increase accessibility across the city. The project involves intricate construction phases, which began in earnest in 2021 and are scheduled to reach completion by 2028. Over the course of these 7 years, the landscape of Houston will see transformative changes. Houston's flat and expansive geography presents unique challenges. Engineers are continuously combating the city's soft soil, which is prone to shifting and sinking. This has led to the innovative use of deep concrete pilings and reinforced steel to ensure the stability of tracks and stations. The project also incorporates elevated sections and raised platforms, designed to withstand Houston's frequent floods, thereby safeguarding the transit system's operational integrity during severe weather conditions. Each new station along the expansion route is being built with more than functionality in mind. They are envisioned as community hubs, equipped with modern amenities, real-time travel information, and artwork reflective of local culture. Despite the benefits, the path hasn't been entirely smooth. Issues ranging from logistical challenges, such as coordinating with existing traffic and utility lines, to public opposition concerning construction disruptions, have tested the project's resilience. The project management team has had to innovate on the fly, employing cutting-edge construction techniques and real-time problem-solving to keep the project on track. Specialized construction methods like the use of silent piling technology to minimize noise in residential areas and the application of advanced GPS and GIS for precision in layout and execution highlight the technical sophistication of this expansion. Let's delve into the monumental Grand Coulee Dam project, an iconic feat of engineering located on the Columbia River in Washington state. Completed in 1942, this project was a cornerstone of the New Deal, aimed at combating the economic woes of the Great Depression while harnessing the power of the mighty Columbia River. With a final price tag of $168 million, it was one of the most expensive and ambitious infrastructure projects of its time. Construction of the Grand Coulee Dam began in 1933 and required the collective effort of over 12,000 workers at its peak. These workers faced numerous challenges, including harsh weather conditions and the logistical complexities of managing such a vast construction site. The dam stretches 523 feet across and stands 550 feet tall, making it the largest concrete structure in the United States. Its creation transformed the region, providing vital hydroelectric power and irrigation that would spur agricultural and economic development. One of the most impressive aspects of the Grand Coulee Dam is its hydroelectric power capacity. Initially, it housed 3 power plants with a total generating capacity of 2280 megawatts. Over the years, expansions have increased this capacity to over 6,800 megawatts, making it one of the largest power producers in the world. The dam also created Lake Roosevelt, a reservoir that spans approximately 125 square miles. This reservoir provides irrigation to over 600,000 acres of farmland, transforming arid regions into fertile agricultural lands. The agricultural productivity of central Washington owes much to the water resources provided by the Grand Coulee Dam. However, the construction of the dam was not without its controversies and challenges. It necessitated the relocation of thousands of people and had significant environmental impacts, particularly on fish populations and the livelihoods of indigenous tribes. The project's success required innovative engineering solutions, such as the use of massive cableways to transport concrete and materials across the site and careful management of the Columbia River's flow. It's time to explore the Crescent Dunes Solar Energy Project next, which is a groundbreaking renewable energy initiative located near Tonopah, Nevada. Completed in 2015, this state-of-the-art solar power plant represents a significant leap in solar energy technology, with a price tag of $1 billion. The Crescent Dunes Solar Energy Project was developed by Solar Reserve and is renowned for its innovative use of concentrated solar power technology. Unlike traditional photovoltaic solar plants, Crescent Dunes uses a central tower surrounded by over 10,000 mirrors, known as heliostats. These mirrors track the sun and focus its energy onto the tower, heating molten salt to extremely high temperatures. One of the key advantages of this system is its ability to store thermal energy, allowing the plant to generate electricity even after the sun has set. The Crescent Dunes facility has a capacity of 110 megawatts and can provide power to approximately 75,000 homes. Building the Crescent Dunes Solar Energy Project was a massive undertaking, requiring the coordination of over 1,000 workers during peak construction phases. The project faced numerous challenges, including logistical hurdles related to transporting and assembling the large number of heliostats and constructing the central tower, which stands at 640 feet tall. The project's location in the Nevada desert posed additional difficulties, such as extreme weather conditions and the need to protect the fragile desert ecosystem. Despite these challenges, the project was completed on time and has set a new standard for solar power plants worldwide. Let's take a look at the impressive Mercedes-Benz Stadium, home to the Atlanta Falcons and Atlanta United FC. Situated in the heart of Atlanta, this sports and entertainment facility is a testament to modern construction, with a staggering cost of $1.6 billion. The Mercedes-Benz Stadium project broke ground in 2014 and opened its doors in August 2017. Designed by Hawk, the stadium covers approximately 2 million square feet and boasts a seating capacity of 71,000, expandable to 75,000 for major events. The stadium is notable for its innovative retractable roof, which resembles a camera aperture and can open or close in just under 10 minutes. This unique design allows the venue to host events in both open-air and climate-controlled environments, providing flexibility for a wide range of activities. One of the standout features of the Mercedes-Benz Stadium is its 360-degree HD Halo video board, which is the largest of its kind in the world. This massive screen, which spans 1,100 feet in circumference, ensures that every spectator has a clear view of the action, no matter where they are seated. Additionally, the stadium is equipped with cutting-edge technology, including high-speed Wi-Fi and numerous LED displays throughout the venue. Constructing the Mercedes-Benz Stadium was a massive endeavor, requiring the efforts of over 4,000 workers during peak periods. The project faced several challenges, including the complexity of the retractable roof mechanism and the need to integrate numerous sustainable design elements. These sustainable features include a rainwater collection and reuse system, a LEED Platinum certification, and over 4,000 solar panels, making it one of the greenest stadiums in the world. Let's delve into the Northgate Link extension, a transformative addition to Seattle's public transportation network. Completed at a cost of $1.9 billion, this project is a cornerstone of the region's efforts to enhance urban mobility and reduce traffic congestion. Breaking ground in 2012 and opening to the public in October 2021, the Northgate Link extension stretches the city's light rail system by 4.3 miles, connecting the University of Washington to Northgate. This crucial extension includes 3 new stations, strategically located to serve key residential and commercial hubs in northern Seattle. A defining feature of the Northgate Link extension is the engineering marvel of its twin tunnels, constructed using state-of-the-art tunnel boring machines. These machines, dubbed Brenda and Pamela, excavated deep beneath the city, navigating complex soil conditions and existing underground infrastructure with remarkable precision. The construction process engaged thousands of workers and required intricate planning and coordination. Each new station is designed with a focus on accessibility, safety, and community integration, featuring modern amenities and public art installations that enhance the commuter experience. The Northgate Link extension significantly reduces travel times, with the journey from Northgate to downtown Seattle now taking just 14 minutes. This improvement is expected to ease road traffic and provide a reliable alternative to driving, fostering greater use of public transportation. The project's impact on Seattle's urban landscape is profound, revitalizing neighborhoods and stimulating economic growth around the new stations. Let's take a closer look at the Second Midtown Tunnel project. Located under the Elizabeth River, the Second Midtown Tunnel connects the cities of Norfolk and Portsmouth. Its construction began in 2012 and reached completion in 2016. This project involved building a new two-lane tunnel parallel to the existing Midtown Tunnel, effectively doubling the capacity of this crucial traffic artery. With a cost of $2.1 billion, the construction process for the Second Midtown Tunnel was both innovative and complex. Unlike traditional tunneling methods, this project used an immersed tube technique. Prefabricated tunnel sections, each weighing approximately 16,000 tons, were constructed in a dry dock. These sections were then floated to the site, submerged into a pre-dug trench on the riverbed, and connected to form the tunnel. This method minimized disruption to river traffic and ensured precise alignment of the tunnel sections. The new tunnel not only alleviates traffic congestion, but also enhances safety and travel times for thousands of commuters. In terms of environmental considerations, the project included several measures to mitigate its impact. This included careful monitoring of water quality during construction and the use of innovative techniques to manage and minimize sediment displacement. The Second Midtown Tunnel also features modern safety enhancements, such as advanced ventilation systems, state-of-the-art lighting, and emergency response facilities. These upgrades ensure the tunnel meets contemporary standards for infrastructure resilience and commuter safety. Comparing this project to other major infrastructure endeavors, the Second Midtown Tunnel stands out for its strategic importance in regional connectivity and its use of advanced construction techniques. Next, let's explore the Las Vegas Convention Center expansion. With a total investment of $4.3 billion, this expansion project significantly enhances the capabilities and allure of one of the world's largest convention centers. Officially completed in 2021, the Las Vegas Convention Center expansion spans 1.4 million square feet, adding substantial new space to the existing facility. The project includes the new West Hall, which alone provides an additional 600,000 square feet of exhibit space, complemented by a stunning 14,000 square foot outdoor terrace offering breathtaking views of the Las Vegas Strip. One of the most innovative aspects of the expansion is the integration of the LVCC Loop, an underground transportation system developed by Elon Musk's The Boring Company. This system features autonomous electric vehicles that transport attendees between the convention center's different halls at high speeds, significantly reducing transit times across the vast complex. The expansion was driven by the growing demand for large-scale event spaces in Las Vegas, which hosts numerous high-profile conventions, trade shows, and corporate events annually. Construction of the expansion required the coordination of thousands of workers and the use of cutting-edge building techniques to ensure that the project met its ambitious goals on time and within budget. Despite the challenges posed by the pandemic, the project team implemented rigorous health and safety protocols to keep the work on track. Sustainability was also a key focus of the expansion, with the new West Hall designed to achieve LEED certification for its environmentally friendly features. These include energy-efficient lighting, water-saving fixtures, and the use of sustainable materials throughout the construction process. In addition to the increased exhibit space, the expansion features advanced technological infrastructure, including high-speed internet and state-of-the-art audiovisual capabilities to meet the needs of modern events and exhibitions. It's time to delve into the American Dream Meadowlands, a massive entertainment and retail complex located in East Rutherford, New Jersey. With a staggering cost of $5 billion, this ambitious project represents one of the largest mall developments in the United States. Officially opened in phases starting in 2019, American Dream Meadowlands covers approximately 3 million square feet. One of the most striking features of American Dream is its Nickelodeon Universe theme park, the largest indoor theme park in the Western Hemisphere. Adjacent to this is the DreamWorks Water Park, which boasts the largest indoor wave pool. The project faced numerous challenges during its development, including financial difficulties and multiple changes in ownership. Originally conceived in early 2000, the development stalled several times due to economic downturns and funding issues. Despite these setbacks, the project was revitalized and eventually brought to completion, marking a significant milestone in the region's commercial landscape. American Dream's indoor ski slope, known as Big Snow, is another highlight of the complex. It is the first indoor real snow ski and snowboard park in North America, offering year-round winter sports activities. This unique attraction allows visitors to enjoy skiing and snowboarding regardless of the season, making it a significant draw for tourists and locals alike. The construction of American Dream Meadowlands required the coordination of thousands of workers and involved complex engineering and architectural solutions to create its diverse range of attractions. The developers also focused on sustainability, incorporating energy-efficient systems and environmentally friendly practices throughout the complex. The project's strategic location near New York City and major transportation hubs enhances its accessibility, attracting visitors from across the region and beyond. It's time to discuss the next megaproject. Welcome to the Treasure Island redevelopment in San Francisco. Set on a man-made island in the heart of San Francisco Bay, this project is transforming a former naval base into a vibrant residential and commercial hub. Treasure Island spans approximately 405 acres. To put that into perspective, it's roughly the size of 300 football fields laid side by side. The project's budget is a whopping $6 billion, earmarked for creating over 8,000 homes, of which a quarter are designated as affordable housing. The plan includes schools, hotels, and over 300 acres of parks, which means green space is central to the island's new identity. Construction began in 2011 and is set to continue in phases through 2035. The scale of manpower and machinery on this site is staggering. At its peak, the project employed thousands of workers, each skilled in various aspects of construction, from engineers and architects to builders and landscapers, all converging to bring this vision to life. One of the most intriguing aspects of the Treasure Island redevelopment is its commitment to sustainability. The island is poised to become one of the most eco-friendly developments in the U.S. with advanced stormwater systems, zero-waste goals, and buildings designed to lead gold standards. But it hasn't been all smooth sailing. The project has faced its share of challenges, from concerns over rising sea levels to remediation of the soil, which was contaminated during its days as a naval base. These issues required innovative solutions such as elevated land to combat potential flooding and extensive cleanup efforts to ensure the safety and sustainability of the new community. The amount of soil moved and treated for the redevelopment could fill over 60 Olympic-sized swimming pools. And if we talk about the infrastructure, the main roadway spanning the island's length is akin to laying down nearly 3 Golden Gate bridges end to end. Let's travel over to the next megaproject, the Los Angeles County Metro Purple Line Extension, which is a massive $9.3 billion rail project that's stretching the definition of urban transit development. Extending the Metro Purple Line by 9 miles, this project is not just about adding tracks. It's about seamlessly connecting key sectors of the city, from the skyscrapers of downtown LA to the vaunted gates of the University of California. Slated for completion in 2027, the Purple Line extension is currently a hive of activity with over 5,000 workers bustling daily. Building a subway in an area prone to earthquakes demands cutting-edge construction techniques. The team employs advanced tunneling methods, including earth pressure balance machines that delicately burrow beneath the city, ensuring minimal disruption to the surface life and structural integrity of the buildings above. This project solves critical transportation problems in one of America's most congested cities by offering a reliable, high-speed alternative to road travel, effectively reducing traffic and the city's carbon footprint. Once operational, it's expected to serve about 4 citizens and riders daily. Comparing this to the scale of other megaprojects around the globe, the Purple Line extension's budget overshadows the construction costs of the new Wembley Stadium in London, illustrating the monumental investment in public infrastructure and the future of Los Angeles. The project's integration of smart technology systems for maintenance and operation sets new standards for public transportation. Next, let's examine the New Orleans Flood Protection System, a monumental infrastructure project designed to safeguard the city from devastating floods. This extensive system, with a staggering investment of $14.5 billion, stands as a critical response to the catastrophic impact of Hurricane Katrina in 2005. The system encompasses a complex network of levees, floodwalls, pump stations, and surge barriers designed to withstand a 100-year storm event. A key component of the system is the Inner Harbor Navigation Canal Surge Barrier, one of the largest civil works projects in the United States. This massive barrier stretches nearly 2 miles and features a series of gates and pumps that can be activated to block storm surges from entering the city. The I-Inc surge barrier alone cost $1.1 billion and plays a vital role in protecting New Orleans from potential flooding. Another significant element is the Lake Borgne surge barrier, which extends for 1.8 miles and is designed to prevent storm surge from entering the Gulf Intracoastal Waterway and the Mississippi River Gulf Outlet. This barrier, coupled with numerous floodwalls and levee improvements, forms a robust defense against rising waters. The construction of the flood protection system was a massive undertaking involving tens of thousands of workers and extensive coordination between federal, state, and local agencies. The project faced numerous challenges, including the technical difficulties of working in a region characterized by soft, shifting soils and the need to protect the unique ecosystems of the Louisiana wetlands. In addition to physical barriers, the system incorporates advanced pump stations capable of removing vast amounts of water from the city's drainage canals. These pumps are essential for managing heavy rainfall and preventing water from accumulating in low-lying areas, which are particularly vulnerable to flooding. But have you ever heard of the Intel semiconductor plant? With an estimated cost of $20 billion, this state-of-the-art facility represents one of the largest and most ambitious semiconductor manufacturing endeavors in the United States. Located in Chandler, Arizona, the project began its construction in 2011 and has seen continuous upgrades to remain at the cutting edge of semiconductor technology. The plant spans several 100,000 square feet and is designed to produce Intel's most advanced chips, including those built on the company's latest process technologies. A standout feature of the Intel semiconductor plant is its use of advanced manufacturing techniques, which enable the production of chips with transistors measuring just a few nanometers in size. This precision is essential for creating the powerful and efficient processors that drive today's electronics, from computers and smartphones to data centers and AI applications. The facility is also a model of sustainability and environmental stewardship. Intel has implemented numerous green initiatives at the plant, including energy-efficient designs, extensive water recycling systems, and waste reduction programs. Intel's plant plays a critical role in the company's global supply chain, helping to meet the ever-growing demand for semiconductors. This demand has been driven by the proliferation of digital devices, the expansion of cloud computing, and the increasing integration of artificial intelligence into various sectors. The plant's production capacity is essential for ensuring that Intel can supply the chips needed to power the technological innovations of today and tomorrow. The strategic importance of the Intel semiconductor plant extends beyond its manufacturing capabilities. It represents a significant investment in the U.S. economy, creating thousands of high-tech jobs and fostering innovation in the semiconductor industry. The plant also contributes to the nation's technological independence, reducing reliance on overseas chip manufacturing and enhancing the resilience of the supply chain. Next up, we have to discuss one of the most expensive megaprojects in the world, called the Hanford Nuclear Reservation Cleanup. Situated in Washington State, the Hanford site was once home to the largest plutonium production facility in the United States, playing a pivotal role during World War II and the Cold War. However, decades of nuclear production have left a legacy of contamination, necessitating an extensive cleanup effort with costs estimated to range between $300 billion and $600 billion. The Hanford Nuclear Reservation spans 586 square miles and includes 9 decommissioned nuclear reactors and numerous processing facilities. The cleanup project, managed by the U.S. Department of Energy, officially began in 1989 following the site's designation as a Superfund site by the Environmental Protection Agency. One of the primary challenges of the Hanford cleanup is dealing with the vast quantities of radioactive waste stored in underground tanks. These tanks, some of which are over 70 years old, have been found to leak, posing a significant threat to the surrounding environment. A critical component of the cleanup is the construction and operation of the waste treatment and immobilization plant, also known as the vitrification plant. This facility aims to convert radioactive waste into a stable glass formed through a process known as vitrification. By immobilizing the waste in glass, the long-term risk of environmental contamination is significantly reduced. The plant is one of the most complex and expensive construction projects at Hanford, with an estimated cost of $17 billion. The cleanup efforts at Hanford also involve the remediation of contaminated soil and groundwater. Advanced technologies and methods, such as pump and treat systems, are employed to remove radioactive contaminants from groundwater and prevent their migration. The project has faced numerous challenges, including technical difficulties, regulatory hurdles, and budget constraints. Despite these challenges, significant progress has been made in reducing immediate risks and advancing long-term remediation goals. Comparatively, the Hanford cleanup is unparalleled in its scope and complexity, reflecting the immense legacy of the United States nuclear weapons program. The project's costs and duration are unprecedented, with estimates suggesting the cleanup could continue for several more decades.
Let's move over to Nevada for the Tesla Gigafactory. With an estimated cost of $16 billion, this massive facility is revolutionizing battery production and energy storage. Gigafactory Tesla is one of the highest volume plants in the world for electric motors, energy storage products, vehicle powertrains, and batteries. Located near Reno, Nevada, the Gigafactory spans 5.3 million square feet, making it one of the largest buildings in the world by footprint. When fully completed, it will cover over 13 million square feet and produce enough batteries to power 500,000 electric vehicles annually. The Gigafactory produces lithium-ion batteries for Tesla electric vehicles and Powerwall energy storage systems. By manufacturing batteries in-house, Tesla reduces costs, increases efficiency, and ensures a stable supply chain. The factory operates on renewable energy, with plans to achieve 100% sustainability. Solar panels cover the roof, and the surrounding area is designed for wind and geothermal energy generation. These efforts align with the mission of Tesla to transition the world to sustainable energy. The Gigafactory has created thousands of jobs in Nevada and attracted additional businesses to the region, boosting the local economy. The expansion is expected to add about 6,500 full-time employees and 4 million square feet of manufacturing space. It has also positioned the US as a leader in battery production and electric vehicle innovation. Despite its achievements, the Gigafactory has faced challenges, including construction delays and supply chain disruptions. Some critics question whether Tesla can meet its ambitious production targets. But the Hudson Tunnel project is arguably even more impressive, which will upgrade some of the most critical infrastructure in America. Beneath the Hudson River lies a vital rail connection between New York and New Jersey. This connection serves over 200,000 daily commuters, making it a lifeline for the Northeast Corridor. The project, part of the Gateway program, aims to modernize these aging tunnels and secure the future of rail travel. The first component is the construction of a new 2-track tunnel. This tunnel will run from the Bergen Palisades in New Jersey to Manhattan. It is designed to add capacity and create redundancy in the system. The second component involves the final phase of the Hudson Yards concrete casing. This section will ensure uninterrupted rail access to Penn Station. The third component is the rehabilitation of the existing North River Tunnel. This tunnel, damaged during Superstorm Sandy in 2012, will be restored to modern standards. Construction is a massive undertaking, involving advanced machinery and precise engineering. Tunnel boring machines will carve through the dense rock beneath the Hudson River. High-capacity cranes will assist in laying massive concrete segments for the tunnels. Specialized rail laying machines will ensure smooth track installation. This process ensures the tunnels are built to withstand modern demands and extreme weather. The new tunnel is set for completion before the rehabilitation of the existing one begins. This strategy minimizes disruptions while maintaining service for commuters. By 2035, the project aims to provide 4 fully operational tracks beneath the Hudson River. The benefits are transformative. The project will eliminate a single point of failure in the rail network. It will create over 95,000 jobs during construction, boosting the local economy. An estimated $19.6 billion in economic activity will be generated throughout the project's life cycle. The new system will also reduce road congestion, cutting greenhouse gas emissions by 2 million tons annually. This is the equivalent of flying 2.6 million people from New York to San Francisco. The Pennsylvania Railroad began design and construction work of the existing North River Tunnel in February 1903. It was opened to revenue service in November 1910. The two-track North River Tunnel was state-of-the-art in the early 20th century. However, its age and design limitations now hinder reliability. In 2012, Superstorm Sandy worsened these issues, flooding the tunnel and causing lasting damage. The Hudson Tunnel project addresses these challenges, ensuring safe and efficient travel for generations. We move over to New York for the Hudson Yards project, a $25 billion mega project on the west side of Manhattan, is the largest private real estate development in America's history. Spanning 28 acres, this transformative project has redefined urban living and set a new standard for mixed-use developments. The project features The Edge, which is the highest outdoor sky deck in the Western Hemisphere. This will include more than 18 million square feet of commercial and residential space, along with more than 100 shops. There'll be a collection of restaurants, approximately 4,000 residences, and affordable housing. Then there is The Shed, a cultural venue that hosts performances, art exhibits, and events. This 14 acres of public open space will also include a 750-seat public school, the inaugural Equinox Hotel with 212 rooms, and a first-of-its-kind microgrid and cogen plant. Hudson Yards includes luxury apartments with stunning views and cutting-edge amenities. There'll also be office spaces for major corporations like Facebook, L'Oreal, and Warner Media. This blend of living and working spaces creates a dynamic, self-sustaining community. The shops and restaurants at Hudson Yards offer a premier shopping and dining experience with high-end retailers and world-class chefs. It has become a destination for locals and tourists alike. Hudson Yards incorporates sustainable design elements, including energy-efficient buildings, green roofs, and a district-wide microgrid for power and heating. Residences feature high ceilings and custom interiors, along with a range of state-of-the-art features. From filtered fresh air ducts to Lutron home automation, the development aims to reduce its environmental footprint while creating a modern urban experience. This mega project has created tens of thousands of jobs and generated billions in economic activity. It has also revitalized the west side of Manhattan, turning a once industrial area into a thriving neighborhood. Hudson Yards has faced criticism for its high costs, exclusivity, and limited affordability. Some argue that it caters to the wealthy while neglecting the needs of lower-income residents. Let's move over to New York for the gigantic 2nd Avenue subway project. This heavily delayed development is now a reality that significantly enhances public transit in New York City. With a price tag of over $4.5 billion for its first phase alone, this project is among the most ambitious and expensive transit ventures in America. The 2nd Avenue subway has been on the drawing board since the 1920s. Financial challenges, political hurdles, and engineering complexities repeatedly stalled the project. After decades of setbacks, Phase 1 finally opened in January 2017. This marked the first major expansion of the subway system in New York City in over 50 years. The initial phase added 3 new stations along 2nd Avenue at 72nd, 86th, and 96th Streets. It has extended the Q train to provide service to the Upper East Side. These stations are state-of-the-art, featuring spacious platforms, elevators, escalators, and vibrant artwork. This makes them some of the most visually appealing ones in the system. The 2nd Avenue subway is far from complete. Phase 2, with an estimated cost of $6 billion. This will extend the line north to Harlem, adding 3 more stations at 106th, 116th, and 125th Streets. Additional phases will eventually stretch the line down to Hanover Square in Lower Manhattan. The proposed full line would be 8.5 miles and 16 stations long, serve a projected 560,000 daily riders, and cost more than $17 billion. This project has dramatically reduced congestion on the overcrowded Lexington Avenue line. This was previously the only subway serving the area. It has also improved connectivity for Upper East Side residents, cutting travel times and boosting property values in the neighborhood. The subway has boosted economic development along 2nd Avenue, attracting new businesses, residential projects, and retail establishments. It has also improved accessibility for low-income and minority communities in East Harlem, addressing long-standing inequities in transit service. Despite its successes, the 2nd Avenue subway has faced criticism for its high costs, delays, and limited scope. Each phase has taken years to plan and build, raising questions about the efficiency of large-scale transit projects in the US. In coming years, the 2nd Avenue subway will continue to transform the transit network in New York City. But we have not talked about Sound Transit 3 just yet, which is a monumental transportation infrastructure project aimed at transforming public transit in the Puget Sound region of Washington state. With an estimated budget of $54 billion, ST3 represents one of the largest mass transit expansions in US history. The project extends the existing light rail, commuter rail, and bus rapid transit systems of the region by over 116 miles. Key elements include new light rail lines connecting Seattle to Everett, Tacoma, Ballard, and West Seattle. The project also expands Sounder commuter rail services to South King and Pierce counties and introduces bus rapid transit corridors for faster and more reliable travel. The backbone of ST3 is its light rail network, which will include 37 new stations, bringing the total to over 70. These stations will provide seamless connectivity to major employment centers, residential neighborhoods, and educational institutions. The extension to Tacoma and Everett will significantly reduce travel times, offering commuters a fast, eco-friendly alternative to driving. Light rail trains would run 20 hours per day and every 3 to 6 minutes during peak hours. The plan requires the purchase of 226 new vehicles to operate on the new lines. Sound Transit 3 incorporates advanced technologies to enhance the passenger experience. New stations will feature real-time arrival information, improved accessibility for people with disabilities, and safe, well-lit environments. Parking facilities at key stations will also be expanded to accommodate the growing demand for park and ride services. The ST3 expansion is expected to create thousands of jobs during its construction phase and stimulate economic activity in surrounding areas. By improving access to affordable housing, education, and healthcare, the project also addresses social equity. This ensures that underserved communities benefit from enhanced connectivity. The ambitious scope of ST3 presents several challenges, including budget management, environmental reviews, and community engagement. The pandemic caused delays and increased costs, prompting a re-evaluation of timelines and priorities. Despite these setbacks, major components of the project are expected to be completed by 2041, with interim phases opening earlier. Sound Transit Board has recently approved the route and station locations for the West Seattle Link extension. This action authorizes the project to move forward into the final design phase. Construction is expected to begin in 2027. By 2040, Sound Transit estimates that its services will carry a total of between 561,000 and 695,000 daily riders, with 69% of all transit trips using rail services. The Miami Signature Bridge is an iconic infrastructure project designed to improve traffic flow and redefine the city's skyline. With a cost of $818 million, this modern bridge combines functionality with architectural beauty, The signature bridge is planned as a 1025-foot-long bridge over NE 2nd Street and Biscayne Boulevard and will redefine the skyline in Miami with 6 massive arches. The largest arch is expected to reach a height of 325 feet and be 650 feet wide. The design of the bridge includes sweeping arches illuminated by LED lights, creating a striking visual effect. It serves as a gateway to downtown Miami, connecting major highways and enhancing the aesthetic appeal of the city. The signature bridge is part of the I-395, SR-836, and I-95 improvement project, addressing congestion in one of the busiest corridors in Miami. By streamlining traffic flow, it reduces travel times and improves safety for drivers and pedestrians. Beyond its practical benefits, the bridge includes public spaces, pedestrian walkways, and green areas underneath. These features transform the area into a vibrant community hub, blending infrastructure with urban living. Construction has faced delays due to weather and logistical issues, but the project remains on track for completion in 2027. We have to talk about the redevelopment of one of the busiest airports in the country, John F. Kennedy International Airport. This project is worth $19 billion and is all set to redefine air travel for one of the busiest hubs in the United States. With over 62 million passengers passing through annually, JFK is integral to global connectivity. The airport generates more than $51 billion in sales and $17.1 billion in wages. This massive project ensures that the airport not only meets current demands, but is also prepared for future growth. The JFK International Airport Master Plan to redevelop the airport into a world-class 21st century airport is being led by Grimshaw and Mott MacDonald. The expansion will result in new terminal complexes on both the south and north sides of the airport. To the south, Terminals 1 and 2 will be replaced with a new terminal served by 23 international gates. On the north side, another upgraded terminal will connect to the existing Terminal 5 and offer 12 international gates, each able to serve larger wide-body aircraft. Other expansion projects include a 16-gate expansion for Terminal 4 and a 3-gate expansion at Terminal 8. The project also focuses on enhancing the passenger experience through modern design, spacious concourses, advanced technology, and sustainable features. Improvements include better check-in areas, automated security systems, and a wider range of retail and dining options. Upgraded baggage handling systems will streamline operations, reducing delays and improving efficiency. To complement the terminal upgrades, the project includes a redesign of roadways and parking areas to ease congestion and improve traffic flow. Expanded air train capacity will provide a seamless connection to public transportation. Similarly, upgrades to taxiways and aprons ensure better aircraft movement on the ground. With new roads, bridges, and enhanced traffic technologies, travelers will have an easier time navigating between terminals. They are also reducing the number of roadway loops from 5 to 2 main loops, making it less confusing for drivers. This will eventually create space for more cars to circle through, but less congestion to stack up. This includes a multi-level parking facility with nearly 2,000 spaces and an eco-friendly timber exterior. A 122-meter pedestrian bridge equipped with rainwater harvesting technology will link it to the new Terminal 1. The expansion has faced challenges, including coordination with airlines, minimizing disruption during construction, and managing costs. The city is also building its own concrete plant to produce the roughly 550,000 square meters expected to be used at JFK. That's enough to fill about 218 Olympic swimming pools. Despite several hurdles, the project remains on track, with completion expected by 2030. Let's travel to Tolosa, a brand new $400 billion future city planned in the States. It's a futuristic city, taking shape in the imagination of tech billionaire Mark Law. Tolosa promises to combine the cleanliness of Tokyo, the diversity of New York, and the social services of Stockholm into a groundbreaking urban design. The name of the city comes from Greek, which means something like highest goal. This refers to both sustainability goals and the diversity of the population. Law got this idea from the economist Henry George, who dreamed of a tax-free, communal form of society as early as the 19th century. However, this has so far only been implemented on a very small scale. This gigantic city, around the size of Chicago, will rise from scratch in the middle of desert, covering 150,000 acres. With a vision for sustainability and equity, Tolosa will feature eco-friendly architecture, renewable energy systems, and a drought-resistant water supply. Its 15-minute city design ensures residents can reach schools, workplaces, and amenities within a quarter-hour commute. Planners are scouting locations in Nevada, Utah, Idaho, Arizona, Texas, and the Appalachian region. Digital renderings by Bianca Ingel's group depict lush greenery on buildings, abundant open spaces, and sunlit streets filled with autonomous vehicles, pedestrians, and bicycles. Fossil fuel-powered vehicles will be banned, creating a clean, quiet, and sustainable transport ecosystem. Smart infrastructure will track energy use, traffic, and public services in real time. Equitism Tower will be built as the Tower of Sustainability. This skyscraper will feature elevated water storage, aeroponic farms, and a photovoltaic roof that generates energy. The tower is designed to share resources efficiently, embodying Tolosa's vision for self-sustaining communities. The first phase of Tolosa will cover 1,500 acres and house 50,000 residents. Estimated costs for this phase alone are $25 billion, while the entire project is expected to exceed $400 billion. Construction will use advanced technologies, including 3D printing, modular construction methods, and renewable materials to minimize environmental impact. Heavy equipment like electric excavators and robotic construction systems will speed up development while maintaining precision. The project is set to break ground by 2030, with a goal of reaching a population of 5 million within 40 years. The governance in Tolosa will emphasize participation and equity, inspired by the philosophy of Henry George. Residents will have a say in budgeting and decision-making processes. Law envisions a city where people, not profits, are at the center, describing it as the most open, fair, and inclusive city in the world. Tolosa's unique economic model, equitism, gives residents shared ownership of city land. A foundation will manage land sales, using profits to fund public services. Once the city thrives, its residents will prosper. However, this model requires strong public and philanthropic support to succeed. Tolosa faces significant hurdles, particularly in water availability. Building in the desert means addressing drought risks and water rights. Critics argue resources might be better spent retrofitting existing cities. For Law, the challenge is proving that starting fresh allows for groundbreaking solutions. The Texas high-speed rail is a bold step toward revolutionizing transportation in the United States. Connecting Dallas and Houston, this $30 billion project aims to bring Japanese Shinkansen technology to the Lone Star State. This offers a 90-minute journey between two of the fastest-growing cities in the nation. With trains traveling at speeds up to 205 miles per hour, it promises to halve travel times and provide a sustainable alternative to congested highways and overcrowded airports. The route spans 240 miles, starting in Dallas and running through Grimes County before reaching Houston. 3 state-of-the-art stations are planned. The Dallas station will be located in the Cedars District, close to major highways and the K. Hutchison Convention Center. The Brazos Valley Station in Grimes County will connect to Texas A&M University, stimulating local economic development. In Houston, the station will rise at the former Northwest Mall site, offering easy access to the energy corridor and other business hubs. The technology driving this project is the Japanese Shinkansen system, renowned for its safety and reliability. Since its induction in 1964, the Shinkansen has achieved an unbelievable record, with 0 passenger fatalities due to accidents. Texas Central, the private company behind the project, plans to use this proven model, adapted to American needs. The trains will feature wide aisles, fast Wi-Fi, and smooth, frequent services, running every 30 minutes at peak times. Construction of the rail line is expected to leverage advanced engineering and machinery. High-capacity cranes, specialized rail-laying machines, and advanced tunneling equipment will be employed to ensure precision and speed. The relatively flat terrain between Dallas and Houston minimizes the need for extensive tunneling or complex infrastructure. This makes the route ideal for high-speed rail. Despite this, the project has faced challenges, including opposition from landowners and questions about financing. Texas is uniquely suited for high-speed rail, with a population of over 29 million and a GDP exceeding $2 trillion. The growing economy and urban expansion of the state create a strong demand for efficient transportation. Dallas and Houston, home to nearly 20 million people combined, are economic powerhouses. The project could eventually expand to include cities like Austin and San Antonio, further increasing its reach and utility. The benefits of the Texas high-speed rail extend beyond convenience. By reducing car and air travel, the project aims to cut greenhouse gas emissions and alleviate road congestion. It's estimated to create 10,000 construction jobs annually and 1,500 permanent jobs once operational. Moreover, it could serve as a model for other high-speed rail projects across the US. This is sparking a new era of sustainable infrastructure. Despite setbacks and uncertainties, the Texas high-speed rail holds immense potential. If successful, it will redefine how Americans travel, combining speed, sustainability, and innovation. While the road ahead is challenging, the vision of a connected, efficient future keeps the project moving forward. The early 2030s could mark the dawn of high-speed rail in America, with Texas leading the charge. We don't have to travel far for the Penn Station Access Project, which is a transformative initiative aimed at improving rail connectivity in New York City. Spearheaded by the MTA, this $2.87 billion project will expand access to Penn Station. More than 600,000 passengers use the station on an average weekday, or up to 1,000 every 90 seconds. It is the busiest passenger transportation facility in the United States and in North America. The project will bring 4 new Metro North Railroad stations to the Bronx: Hunts Point, Parkchester, Van Nest, Morris Park, and Co-op City. These stations will connect directly to Penn Station, reducing travel times and offering a convenient alternative to crowded roadways. By 2027, commuters will have a seamless link between the Bronx and Manhattan, cutting up to 75 minutes off daily commutes. To support this enhanced service, 19 miles of Hellgate Line in Amtrak are being upgraded. This includes track rehabilitation, modernized signals, and updated power and communication systems. Reconfigured interlockings will improve train routing and increase the reliability of both Metro North and Amtrak services. Construction began in December 2022 and is progressing steadily. Long-term single-track outages have allowed crews to work efficiently, improving safety and productivity. Key milestones include the commissioning of the Leggett interlocking in 2024, a crucial component that will enhance operational flexibility. Throughout the construction, public meetings are being held to keep communities informed of progress and upcoming phases. The Penn Station Access Project is expected to drive economic growth in the East Bronx. With 4 new stations, the area will see increased property values, job opportunities, and business development. By improving public transit, the project is all set to reduce traffic congestion and lower air pollution. Fewer cars on the road mean a cleaner environment and more sustainable urban living. The benefits of this project extend far beyond the Bronx. A new one-seat ride between Penn Station and the East Bronx, Westchester, and Connecticut will improve connectivity across the region. The project introduces a second Metro North route into Manhattan, providing an alternative to Grand Central Terminal. This added capacity will support the growing demand for rail service in one of the busiest corridors in the country.
We move over to Seattle next, where the Alaskan Way Viaduct Replacement Tunnel project stands. This project replaced the aging and seismically vulnerable Alaskan Way Viaduct with a 1.7-mile-long double-deck highway tunnel running beneath downtown Seattle. The tunnel is part of a State Route 99 and was constructed to improve safety, reduce congestion, and enhance the city's waterfront area. The tunnel's construction utilized a tunnel boring machine named Bertha, which was, at the time, the largest of its kind in the world, with a diameter of 57.5 feet. Bertha's journey began in July 2013, but the project faced significant challenges soon after. In December 2013, the TBM came to an unexpected halt after encountering a steel pipe, which damaged the machine's cutting blades. This led to a prolonged repair period that lasted nearly 2 years. The TBM was eventually repaired by excavating a recovery shaft from which engineers accessed and lifted the front of the machine to replace the damaged parts. The tunnel boring process resumed in December 2015, and Bertha continued to carve its way beneath Seattle at an average depth of about 200 feet below the surface. The tunnel was constructed using a segmented ring system, where each ring is made up of 10 precast concrete segments. As Bertha moved forward, these segments were installed to form the tunnel's lining, providing structural support and preventing groundwater ingress. To ensure the tunnel's long-term durability and safety, engineers used a comprehensive monitoring system to track Bertha's progress and the surrounding ground conditions in real time. This system included sensors embedded in this tunnel's lining and the ground above, allowing for immediate detection of any movement or settlement that could indicate potential issues. One of the complex aspects of the construction was managing the groundwater and ensuring the tunnel remained watertight. The tunnel passes through the Duwamish River's alluvial deposits, which are prone to high groundwater pressure. To address this, Bertha was equipped with a pressurized front shield that balanced the pressure at the tunnel face, preventing water from flooding the excavation chamber. The final breakthrough occurred in April 2017, marking the completion of Bertha's journey. However, the project was far from over, as extensive work was required to outfit the tunnel with necessary infrastructure, including roadways, ventilation systems, fire suppression systems, and emergency egress routes. The tunnel officially opened to traffic in February 2019, replacing the viaduct and transforming Seattle's waterfront. It's time to move over to Utah for the Salt Lake City International Airport redevelopment. Initiated in 2014, the project involves a complete overhaul of the existing facilities, including the construction of a new terminal and concourses, all aimed at modernizing the airport to handle increasing passenger demands and improving seismic resilience. The construction of the new terminal and concourses, involving several major contractors, is characterized by significant engineering challenges and innovative solutions. The first phase of the project, completed in 2020, included the construction of a 900,000 square foot terminal and the west portions of 2 linear concourses. This phase introduced 45 new gates and a 3,600 vehicle parking garage, representing the largest public works project in Utah's history. A critical aspect of the construction was addressing the seismic risk, given the airport's proximity to the Wasatch Fault, an active seismic zone. To ensure the structural integrity of the new facilities, engineers installed 1,020 steel piles to support the foundations, ensuring the building could withstand potential earthquakes. These piles, driven deep into the ground, provide a stable base for the large terminal structures, which feature a 3-level design with expansive use of steel and concrete. The new terminal's design emphasizes both functionality and aesthetics, with the use of high-performance glazing and large open spaces that draw natural light into the building. This not only creates a welcoming environment for passengers, but also helps reduce energy consumption. The building's layout, with elevated roadways and separate levels of arriving and departing passengers, enhances traffic flow and minimizes congestion. Another significant feature of the project is the 7-mile-long baggage handling system, one of the most advanced in the country. This system, designed to efficiently manage the high volume of passenger baggage, includes large radius turns and wide conveyor belts, capable of handling oversized items like skis and golf clubs. The system is equipped with automated screening capabilities, reducing manual handling and enhancing the overall efficiency of airport operations. The construction of the new parking garage, which doubles the capacity of the previous facility, involved significant structural work. The garage was built using 90,000 cubic yards of concrete and 9,000 tons of rebar, ensuring its durability and capacity to accommodate the increased traffic expected with the airport's expansion. But we have to talk about the largest LNG projects ever in the United States. The Rio Grande LNG terminal, located at the port of Brownsville in Texas, aims to become a major LNG export facility that will handle up to 27 million tons per annum of liquefied natural gas once fully operational. The terminal's design includes significant infrastructure, such as multiple LNG storage tanks, each capable of holding 180,000 cubic meters of LNG, and 2 marine berths to accommodate LNG carriers of up to 185,000 cubic meters capacity. One of the engineering challenges of the project is the site's location along the Brownsville Ship Channel, a highly active industrial waterway with specific environmental and logistical requirements. The construction site required extensive preparation, including soil stabilization and the installation of a comprehensive levee system around the perimeter to protect against flooding and manage stormwater runoff. The soil stabilization process involved deep mixing techniques to ensure a solid foundation for the massive structures, particularly in the areas where the liquefaction trains and storage tanks are being built. The LNG production process at the terminal involves cooling natural gas to -162 degrees Celsius to liquefy it, reducing its volume by about 600 times for easier storage and transportation. This process demands substantial energy, requiring the installation of robust power generation facilities and cooling systems. The engineering work includes laying down extensive pipelines to bring feed gas to the site and distributing it to the liquefaction trains. The liquefaction trains themselves are highly complex systems, each containing multiple stages of compression and heat exchange to achieve the necessary cooling of the gas. These trains are built using modular construction techniques, allowing large components to be prefabricated off-site and then transported to Brownsville for assembly. This approach minimizes on-site construction time and reduces potential delays. The terminal also includes significant safety and monitoring systems. Given the flammable nature of LNG, the design integrates advanced fire detection and suppression systems, extensive monitoring of gas leaks, and robust emergency response plans. Additionally, the terminal will feature a network of control rooms and automation systems to manage the operation of the liquefaction trains, storage tanks, and loading berths efficiently and safely. The engineering behind the Rio Grande LNG terminal also includes provisions for future expansion. The site's being prepared to potentially add additional liquefaction trains and storage capacity as market demands grow. This forward-thinking approach to the terminal's design ensures that it can adapt to future energy needs. Next up, it's time to travel over to Boston to talk about the Ted Williams Tunnel, which is a key component of the larger Central Artery project. The tunnel, which connects South Boston to Logan International Airport, was constructed to alleviate congestion and provide a direct route under Boston Harbor. Construction of the tunnel began in 1991 and was completed in 1995, with the tunnel officially opening to traffic in December 1995. The project is notable for being the first major tunnel in the United States constructed using an immersed tube technique. This method involved constructing the tunnel sections on land and then floating them to the site, sinking them into pre-dredged trenches on the harbor floor and connecting them underwater. The tunnel comprises 12 precast concrete sections, each approximately 325 feet long and weighing about 23,000 tons. These sections were built at a casting basin in East Boston, floated into position in Boston Harbor, and then carefully submerged into place. The construction of the tunnel required extensive dredging of Boston Harbor to create the trench where the tunnel sections would be placed. This dredging was a significant logistical challenge, given the need to manage harbor traffic and ensure the environmental safety of the surrounding waters. The trench was approximately 50 feet deep with a width of around 90 feet. After the tunnel sections were placed in the trench, they were connected and sealed together to create a watertight structure. One of the most critical aspects of the tunnel's construction was ensuring the sections were perfectly aligned and securely connected underwater. To achieve this, engineers used a combination of hydraulic jacks, precise surveying equipment, and underwater divers. The alignment and sealing process required meticulous attention to detail to prevent leaks and ensure the long-term integrity of the tunnel. The tunnel structure is composed of high-strength concrete, reinforced with steel rebar to withstand the pressures of being submerged underwater and the loads from traffic above. The tunnel walls are 3 feet thick, providing significant durability and resistance to potential impacts or structural shifts. The interior of the tunnel features a ventilation system designed to manage vehicle emissions and ensure air quality within the tunnel, with large fans installed at intervals to circulate fresh air. Another engineering challenge was the need to connect the submerged tunnel sections to the land-based approach structures on both sides of the harbor. This transition between the immersed tube and the cut-and-cover tunnels required careful design to accommodate the different construction methods and ensure a seamless connection. Next up, let's discuss the Glen Canyon Dam that's located on the Colorado River in Arizona. Constructed between 1956 and 1966, the dam was designed to provide water storage, flood control, and hydroelectric power generation for the southwestern United States. The dam created Lake Powell, one of the largest man-made reservoirs in the country, which extends into southern Utah. The construction of the Glen Canyon Dam was a massive undertaking that required extensive planning, innovation, and the overcoming of significant engineering challenges. The dam is a concrete arch-gravity structure standing 710 feet high and 1,560 feet long. It was designed to harness the power of the Colorado River, while also providing a stable water supply for agricultural, industrial, and urban use in the region. One of the critical challenges during the construction of the Glen Canyon Dam was the remote location. The site, located in a remote area of the Colorado Plateau, was difficult to access, requiring the construction of roads, bridges, and other infrastructure to support the transport of materials and workers. The dam's construction also involved building the Glen Canyon Bridge, a steel arch bridge that spans 1,271 feet across the canyon, providing essential access to both sides of the construction site. To manage the Colorado River's flow during construction, engineers had to divert the river through tunnels carved into the canyon walls. 2 diversion tunnels, each with a diameter of 41 feet, were excavated through the sandstone bedrock on either side of the river. These tunnels, lined with concrete, allowed the river to bypass the construction site, ensuring that the dam could be built in a dry environment. The foundation of the dam required extensive preparation. Workers excavated the riverbeds down to solid bedrock and ensured a stable foundation for the massive concrete structure. The dam's foundation is key to its stability, allowing it to bear the immense pressure exerted by the reservoir. The concrete used in the dam was placed in blocks, each measuring about 50 feet square and 7.5 feet high. The dam was constructed in a series of these blocks, which were keyed and grounded together to form a solid monolithic structure. The dam's power plant, located at the base of the structure, houses 8 hydroelectric turbines that generate up to 1,320 megawatts of electricity. This power generation capacity has been vital in supporting the electric grid of the southwestern United States. The power plant is also equipped with a series of penstocks, large pipes that carry water from the reservoir to the turbines, allowing for the controlled water release and energy production. But how about one of the busiest bridges in the world? Constructed between 1927 and 1931, the George Washington Bridge was designed by Swiss-American engineer Othmar Ammann, who utilized innovative techniques to create what was then the largest suspension bridge in the world. The bridge's main span, which measures 3,500 feet, was a record-breaking achievement at the time of its completion. The bridge's design includes 2 main cables, each 36.5 inches in diameter, made up of around 26,000 individual wires bound together. These cables were manufactured and spun on-site using the saddle method, which involved spinning the wires from one anchorage over the tower tops and down to the other anchorage. This method allowed for precise tensioning of the cables and was crucial for the bridge's structural integrity. The bridge's two towers, each standing 604 feet tall, are composed of steel and rest on massive concrete foundations anchored into the bedrock beneath the river. The towers were initially designed to be clad in granite, but due to the economic constraints of the Great Depression, they were left as exposed steel, which has become an iconic feature of the bridge. The open steel lattice structure of the towers not only provides the necessary strength, but also reduces wind resistance, which is vital for the stability of such a large suspension bridge. The construction of the bridge required significant feats of engineering and logistics. Workers built caissons on the riverbed to serve as foundations for the towers. They were sunk to depths of up to 80 feet below the water level and filled with concrete to provide a stable base for the towers. Building the caissons was one of the most challenging parts of the construction, requiring deep excavation and precise engineering to ensure stability. The bridge's deck was initially designed to carry 6 lanes of traffic, but due to the structure's robustness and foresight in design, a second deck was added in 1962, increasing the total capacity to 14 lanes. This lower deck, known as Martha, was added without interrupting the flow of traffic on the upper deck, a significant engineering accomplishment that showcased the bridge's adaptability and demands forward-thinking design. The George Washington Bridge was completed ahead of schedule and under budget, which is a testament to the efficiency and skill of Amman and his team. It opened to traffic on October 24, 19, and has since become a vital transportation link, handling more than 100 million vehicles annually. Let's travel over to the state of Missouri to investigate Kansas City International Airport's transformed megaproject. The airport has undergone a significant transformation with the construction of a new terminal, replacing the old 3-terminal layout that's been in use in the airport's opening since 1972. The new terminal spans approximately 1 million square feet and features a single consolidated structure that replaces the outdated horseshoe-shaped terminal. This design was intended to streamline operations and enhance passenger flow, reducing the complexity of navigating between different terminals. A key aspect of the construction was the airport's location on a former floodplain. Engineers had to ensure that the new terminal was built on solid ground that could withstand potential flooding. The site was prepared by excavating over 1.1 million cubic yards of soil and placing fill material to elevate the ground level, ensuring a stable foundation. In addition, extensive underground utilities were installed to support the terminal's operations. The new terminal structure is primarily composed of steel and reinforced concrete, providing both durability and flexibility. The use of structural steel allowed for large open spaces within the terminal, which is a significant improvement over the cramped and outdated spaces of the previous terminals. The roof of the terminal is supported by a series of large steel trusses, creating a vast column-free interior that enhances the feeling of openness and allows for better natural lighting. One of the challenging engineering aspects of the project was the integration of modern baggage handling and security systems. The terminal includes an advanced baggage handling system capable of processing thousands of bags per hour, which features such an automated sorting and tracking to improve efficiency and reduce the risk of lost luggage. The security checkpoints equipped with the latest screening technology, including automated screening lanes that expedite the process while maintaining high levels of security. The terminal's construction also included the development of new roadways and parking facilities to accommodate the increased passenger capacity. A new multi-level parking garage with over 6,000 spaces was built adjacent to the terminal, providing easy access for passengers and reducing the need for long shuttle rides from distant parking lots. The roads leading to the terminal were reconfigured to improve traffic flow and reduce congestion, with separate lanes for private vehicles, taxis, and buses.